So very good morning to one and all. So we have today is the last day of this conference. Today we have scientist from ISEC, Krishnamuraju sir, and today's chair Professor Usha Ravindra and co-chair M.E. Vijay Kumar sir. Please come on to the dais. Welcome you sir, and welcome you madam, and welcome our Professor Sakuntala madam and Ramakrishna Reddy sir and all of you for this last day of the conference. Today we have a co-chair Dr. M.E. Vijay Kumar. He did his BFSc, MFSc and PhD from College of Fisheries, Mangalore. Presently working in ICR CIFRI, that is Central Institute of Freshwater Research Institute, Esrughatta, Bangalore. He has more than 20 years of experience in the field of fisheries, published more than 25 research publications in national and international journals of repute. And his research area, fish biodiversity, reservoir fisheries management and fish production enhancement methodologies. He is also an executive member of Journal of Society of Fisheries and Life Sciences, College of Fisheries Alumni Association, member of Indian Science Congress. With this brief introduction about Vijay Kumar sir. So thank you sir for accepting as a co-chair. I request you to please introduce today's session of the chair, Professor Usha Ravindra madam.
Very good morning to all. Respected speaker of the day and respected co-chair and respected Professor Kstacademy madam and other dignitaries and all participants. Since past 2 days you have been listening climate change and other things, and I hope all students enjoyed the evening cultural program. So Mr. Srinivas made me to go out to bring something and he enjoyed, and he could able to show the glimpses of your activities, and it was very nice and you people enjoyed. And I would like to tell one thing. This is the place where many eminent scientists are coming here, and we cannot easily access them. You take IAC, NCBS, whether university professors, GKVK and all, whereas in KSTA, Dr. Ramesh sir and his team, they are bringing many eminent scientists here, and it is a great opportunity for you people to interact with the eminent scientists and make connections. When you come for conference, not chit-chat with your own friends, you interact with others, interact with scientists, you get the contacts. So otherwise, even NCBS and all, you cannot think of getting inside and meet scientists. And we are fortunate enough to see many eminent scientists here. Thank you all. So with this, I would like to introduce our chair, Dr. Usha Ravindra madam. She is currently working as a professor and ed in All India Research Project on Women in Agriculture, and also worked in different capacities with a total of 29 years of service. Madam has guided more than 12 MSc students and 12 PhD students in food science and nutrition. So currently she has handled 19 research projects from both central and state government, funded by DBT, DST, RKVY and other funding agencies. Main thrust areas like improvement of livelihood of farm families, processing and value addition of soybean, millets, underutilized greens, zinc nutrition, midday meal program, and other impact studies. Currently, she is handling one DBT funded project on the rural-urban interface of Bangalore, a space of transition in agriculture, economics, and society. Phase 2, food and nutrition and validation of in vitro anti-proliferative activity against human cancer cells and glycemic assay of pigmented rice genotype and processing and value addition to minor millets. And Madam has collaborated in many varieties of in developing sugarcane, rice variety, and ragi variety, and she has commercialized 12 technologies related to liquid jaggery making, jackfruit, rind-based products, moringa green teas, moringa chocolates, chia, many other products Madam has developed, and she has already have 3 patents related to community engagement, extension activities, and she has organized about 800 training programs on different aspects of food and nutrition for empowerment of women, trained officers of different departments like horticulture department, income tax department, and other related department officials. And she has published more than 80 research papers, many books and leaflet, textbooks, several folders she has published, and she has got many awards to her cap, like she got a gold medal in a PhD, best paper award for okay madam, best paper award for 4 papers in international and national conferences, and she got best agricultural scientist award for the year 2011, and she got best poster awards, and received felicitation from Karnataka Arya Mahila Mahasabha, and she has received best woman scientist award during 107th Indian Science Congress held at GKVK Bangalore, and she has recognition from All India Radio, and like that many awards madam has received. That is the inspiration for us. So welcome you madam, and over to you. Thank you.
Good morning all. Good morning. Good morning. Thank you. Very warm welcome to all of you. I think Dr. Vijay Kumar has read in detail. That was not at all necessary, in fact. I thought he will introduce in me just 3-4 lines. But now I have a privilege of introducing today's speaker, Dr. Krishna Raj. Wonderful biodata he is having, though it is a very small paragraph, but it's really wonderful. I hope many youngsters, including me, we get motivated to achieve greater heights. Dr. Krishna Raj is a professor and vice chairman, that's the dean at All India Research Institute, ISAC, Bangalore. He has PhD in economics. He served as ICCR chair, professor on Indian economy under MOEA, Government of India, at Hankook University, Foreign Studies, Seoul, that is Korea. He was a visiting scholar at the University of Clare, USA. He was awarded with the Sir Ratan Tata Trust Research Fellowship. His research in environmental economics and sustainable development received great recognition, and his research findings helped in framing policies by the government of Karnataka as well as country, India. He was invited to Niti Aayog think tank on G20 workshop for policy suggestions. He is currently a consultant economist for ADB Philippines. He is a member of several expert committees which include NGT, Government of India. He served as a panel of expert in many live television channels. So with this brief intro from the, I think has given very small brief. Probably students can have a very good interaction after his talk. So I am very eager to listen about his views and his thoughts, mainly with climate resilience and mitigation strategies. So with this, I welcome Dr. Krishna Raj for the session.
Good morning, one and all. I am highly privileged and humbled to stand before all of you. The very distinguished scientists are here. Professor Shakuntala Madam is here. Professor Reddy is here. Professor Usha Ravindranath, Dr. M.E. Vijay Kumar, and Srinivas, and Director Ramesh, and all the scientists, young scientists from all over India. Thanks to Karnataka Science and Technology Academy for having invited me to this very interesting national conference on climate change, climate resilience and sustainable development. So I am not a pure scientist, I am a social scientist. My background is economics and I am an economist. From my perspective, I try to analyze the relationship between climate change, economic development and also sustainable development. As you would know, India is facing one of the policy challenges, or we can also call it as policy trade-off between achieving economic development on the one hand, on the other hand it has to control, mitigate or adapt to the climate situation. Because Government of India has already submitted to COP 27 and also Paris Agreement, so it will achieve net zero emission by 2070. So yesterday I wrote a piece for the Tribune where I have explained in detail how the countries of the world are transiting towards achieving net zero emission. So where I criticized in the background of there was a United Nations report, production gap report 2023, you should go through, and also the whether the countries going to meet the net zero emission and reduce the or control the average temperature to 1.5 degrees Celsius by 2040 or 2050. So this is a great challenge. So on the one hand, we need to lift out millions of people, around 40% of the population out of poverty. So economic development is very, very inevitable. On the other hand, we need to meet climate targets. So this is the challenge. In this context, I am talking about the issues concerning. So there are twin problems the world today is facing. One is that economic or income inequality. Another one is the climate change or environmental degradation. So how these two issues have originated in the last 20 to 30 years. The pollution started after 1980s. You know that Brundtland Commission brought out its own report on how to achieve sustainable development. Before that, there was a limit to economic growth conference. And after that, there was a Earth Summit in 1992. So in this way, there are, on the one hand, the United Nations organization has been pushing its policies for sustainable development. On the other hand, the World Bank and WTO and IMF, they are pushing for capitalism and production and consumption. So that leads to economic growth of all the world countries. So this is how at the macro level things are happening. Policy decisions are made. So if you look at the capitalism as a model of economic development we have adopted since 1980s. In India, 1991 onwards, we adopted the policy of liberalization, globalization and privatization. So that is also known as capitalism or free market economy, which is accepted as economic system for economic development in 1991 onwards. So in the market economy, you should understand that the majority of capital goods are owned and by the private individuals and business. Earlier there was a mixed economic policy. Both these resources owned by the government as well as private individuals or private sector. But after 1991, most of the resources, including natural resources, I mean to say, they have been entrusted to private sector, thinking that the market takes care of efficiency and equilibrium, where wherever there is a wastage of resources, that will be reduced due to availability of competition in the market and also availability of technology and minimization of cost. So this was the myth actually. That was foreseen this will happen. But what happened is that the production of goods and services is based on the forces of supply and demand in the market economy. So that did not have the efficient management of certain resources, especially natural resources. Even today the market fails to account the natural resources. So most of the goods and services, for example oxygen, water and others, they are not traded in the market. As a result, there is a market failure and pollution arises. So government has no or little control over the market economy, and the policy says that the government should not interfere in the private sector, and that should be given freedom to produce goods and services. So this has led to two economic or income inequality, led to two problems. One is income inequality in the world and the environmental pollution or degradation. So there is a huge gap in literature, especially in scientific literature, to understand the relationship between these two. This calls for wider debate on whether world's remarkable achievement in economic growth has reflected in its environmental outcome and income inequality. So if you look at the, in this context, if you look at the IPCC report, United Nations IPCC report brought out in 2022, assessment report 6, it is based on physical sciences for climate change, which predicts quicker global warming than anticipated. So earlier they anticipated the climate change may go around 1.1 degrees Celsius to 1.25 degrees Celsius. But this is the report for the first time it has predicted that the climate change may go up to 2 degrees Celsius at the end of this century. So this report is very scientific in nature. It collects 14,000 peer-reviewed studies published by the scientists. Based on that, these inferences or findings have been arrived. So with the increasing demand for and dependence on fossil fuels, the Earth's temperature will most probably increase to 1.5 by 2040 and 2 degrees Celsius by the end of the 21st century. So this is very alarming or also danger the world community is going to face on the onslaught of climate change, due to onslaught of climate change. So it is also projected by the UN IPCC year 6 that if the present rate of increase in greenhouse gases continues, the world will obviously fail to limit the world's average temperature by less than 2 degrees Celsius. Just you imagine, we have currently 1 degree Celsius average Celsius temperature increase. We are unable to bear the heat and also the warmth. So if it increases to 1.5 degrees Celsius or even 2 degrees Celsius, so most of these small flora and fauna, they may not sustain. So one of the reasons for emergence of COVID-19 2019 is due to the relationship between man and animal. So basically the bats that carried the virus to the human beings that led to pandemic like coronavirus. So still the world is so uncertain in terms of how these bacteria and others they behave under the climatic conditions, because they try to adapt to the situation, and wherever they find some host, then they will go and find the place. So certainly there are limited forest resources, and they certainly come to human beings in one way or the other. So this leads to several problems. This report states that unequivocal that humans have warmed the planet, causing widespread and rapid changes to Earth's oceans, ice and land surfaces. So these outcomes begs some questions, poses some questions, where we went wrong in our economic policies. So I am not going to deal with several economic policies, how they went wrong and other things, but due to time constraint, but I'll provide you some understanding about these policies in the later slides. Okay. So the neoliberal policy of capitalism. The environmental degradation is the byproduct of unsustainable trends in consumption and production patterns of neoliberal policy, which basically relies on weak view of sustainability. That assumes that, what is weak view of sustainability? That assumes that natural capital and man-made capital are essentially substitutable, and there is no fundamental difference between them for generating well-being. So this is the major problem of scientific understanding about natural capital and man-made capital or produced capital. So as long as produced or man-made capital increases at the cost of natural capital, there is no problem according to weak sustainability school. But there is also contradictory school of thought, that is not contradictory, but in contrast to this school of thought, there is a strong sustainability view. There it says, they say that there is no perfect substitution between the natural capital and man-made capital, and natural capital cannot be produced by human beings, such as the rain, the water, the forest and others. So they need to, especially the ecosystem services. So therefore we cannot trust the weak sustainability school of thought. So it assumes that the only necessary condition is that the total value of aggregate stock of capital should be at least maintained, if not increased, for the sake of future generation. So the weak sustainability school argues that as long as the human and man-made capital increases, on the other hand human capital decreases, so the value of the total assets of these three capitals should be maintained. So this view suggests that natural resources can be substituted or interchanged with manufactured goods and services. So this has led to this problem today. So there was no importance has been given, even today there is no importance has been given to the natural capital in terms of its contribution to our per capita income or GDP. So then what happened? This has led to this problem. Economic growth leads to CO2 emissions. We are driving cars, heating up the environment through construction of buildings, and cooking and air travel and many other economic activities have resulted in rising CO2 concentrations in the stratosphere, and other forces lead to climate change, temperature rise and precipitation, variations in precipitation, sea level rise, and ice caps are receding, etc. And this lead to climate change, which imposes ecological and economic impacts or cost, lower corn yields, especially in agriculture, coastal flooding, ocean acidification, and so on. And I can give several examples of the climate change implications. So then comes the climate adaptation and resilience policies. Climate change policies reduce emissions, cap and trade, carbon taxes and regulations, where economics comes back once again, how to regulate these activities. So then we need to understand whether climate change a disaster of and for economic development. Climate change is a disaster of economic development, and whether economic development is disaster for climate change and climate change is disaster for economic development. That is the interrelationship we need to understand. First we developed, now it resulted in climate change. Now climate change is impacting on economic activities, that is reducing the GDP and the health and other things. So high carbon economy has helped foster economic growth in recent decades, and at the same time it continues to pose a great threat to economic development. The climate change has rapidly transformed the world in the 21st century. Already 1 degree Celsius has been increased in the last 1 decade. The average surface temperature is 0.9 degrees Celsius warmer in 2020. First it was recorded in 2020, that was the highest temperature on the earth. The climate change is the result of cost of ignoring the rules of nature by high carbon economies of the world, especially the developed countries. They are still contributing to emissions of more gases, greenhouse gases. So therefore we can call it as climate change is a recipe for economic disaster. The emission of greenhouse gases is unprecedented, and the contribution by different economic activities including electricity it generates, it contributes 25% of greenhouse gas emissions. Industry contributes 21% of greenhouse gas emission, and agriculture 24%, transportation 14%, building 6%, and other energy 10%. So if you look at this bar diagram, before 1950s, the world's temperature or the average temperature was less than 0, that is negative. So after 1950s, after the Second World War, the economic activities have picked up largely. As a result, the global average temperature has increased to 1 degree Celsius. So this is the result of economic development we carried out after 1950s. Why this is so? This is mainly due to we are using excessive coal, we are depending on coal, oil and gas, and nuclear and renewable energy resources are even today less. It means that 85 to 90% of our energy needs are met by the fossil fuels. Fossil fuels are coal, oil and gas. So what is the implication? The implication is that CO2 emission. How much is the CO2 emission from fuel combustion? It is in 1 million tons carbon dioxide equivalent. First, let us talk about this one. Yes, this one, I skipped this one. First, total energy consumption breakdown by country. In terms of million tons of oil equivalent, look at China. China consumes highest, 3,381 million tons of oil equivalent, followed by United States and followed by India, Russia and Japan. So this has resulted in this one, CO2 emission from fuel combustion. The China, which consumes high energy, which also produces million tons of carbon dioxide, followed by United States and followed by India and Russia and other countries. So the major economies that are contributing to climate change are China, United States and India and Russia. These are the countries, particularly the China, which is the biggest contributor to climate change. So this slide gives you an idea how China in Asia, China is alone, this is Asia's energy needs is increasing tremendously over a period of time. Whereas in case of other America and European countries and other countries, the energy needs are almost the same. But the energy demands are increasing in Asia alone. So increasing energy use in Asia, China alone consumes 24% of the world's energy. So other countries are consuming at the same level. So 24% of the global energy means China is the biggest contributor for climate change. But the energy use per capita in the world is varying. Look at India's energy per capita, which is less than the United States, Canada, Russia, even Saudi Arabia, and Australia, and even China. Our energy per capita energy consumption is very less. You can understand from this slide. India's energy carbon footprints is 1.57 tons per head, whereas in case of United States it is 14.95. It is almost 15 tons per head, followed by Canada, like that. So even though we have a huge population in India, but our energy per capita energy consumption is less. As a result, the carbon footprint is also less. Look at the energy consumption in India alone. So India is also heavily depending on fossil fuels for energy needs, primary energy, that is oil, coal and gas, that almost contribute to 85% of our energy needs, even though there are non-renewable energy resources production is increasing over a period of time, but still our energy needs are completely met by the fossil fuels. As a result, if you look at vehicular growth in India, which is also increasing over a period of time, you know that India is facing one of the traffic congestion. Recently I have submitted a report to Government of Karnataka on traffic congestion. So this clearly shows that the vehicular growth is enormous over a period of two-wheelers you can find, cars you can find, buses. It is as percentage of total vehicle population, goods vehicle. If total you look at the 0.30 in 1951, now it has gone to 295.8 million vehicles on the roads. This has led to emission of carbon in India. It is vertically growing. Carbon emission is vertically growing except this COVID period. So per capita emission is also increasing. Kilotons of CO2 is also increasing, and also the per metric tons per capita is also increasing over a period of time. Apart from that, the other sectors which are also contributing, electricity and heat and agriculture, manufacturing, transport and other sectors also contributing to carbon emission, CO2 emission and other gases. So if you look at the data related to pollution in metropolitan cities, especially in Gandhinagar, Delhi, Bangalore, Ahmedabad, Chennai, Hyderabad, Kolkata, PM10 and PM2.5 trends are alarmingly increasing. If you look at Delhi, Delhi is almost Delhiites breathing polluted air only. Both PM10 and PM2.5, they are at the dangerous level. Even they touch 500. Recently I went to Delhi, I was getting a giddiness after landing in Delhi airport. So that is the situation. I don't know how Delhi people are breathing this bad air, and it is very, very carcinogenic in nature. And if you look at other key indicators in India as percentage of global average between comparison between 2000 and 2019, The GDP per capita is increasing, energy demand per capita is increasing, oil demand per capita is increasing, coal demand per capita is increasing, residential energy use is also increasing, steel and cement use increasing, car ownership is also increasing. As a result, CO2 emission per capita is also increasing over a period of time. So this is how the economic activities have led to these problems. So these figures clearly show that there is a strong association between increasing demand for energy and rise in temperature levels. The growth of high carbon economy is also linked to the neoliberal economic policy of capitalism of mass production and mass consumption adopted by all the countries of the world since 1980s. However, the carbon footprints vary with income inequality, and the economy in the economy, the rich produce more carbon footprints than the poor. So, what are the risks involved with this economic activity? So, the climate change is led to three problems. One is sensitivity, another one is resilience and vulnerability. The sensitivity is the degree or magnitude or rate at which economic and environmental system are affected or stressed either adversely or beneficially by the variability in climate change. So the sensitivity is the economy or environmental system is being affected due to presence of carbon dioxide or greenhouse gases. Either adversely or beneficial. For example, so Russia is beneficial because most of this land is ice capped. If ice caps recedes, they gain more land. That will be benefited. But in case of other countries, tropical countries, so the flooding in coastal areas lead to several problems like that. So resilience is the ability of an economic and environmental system to recover from the effect of an extreme climate variability that might have caused harmful impacts. So resilience is the economic and environmental system, ability of the system to recover from these floods and heat waves and drought and other things. But the rich countries, they are able to overcome such droughts or natural disasters. But in case of poor countries like India, they are unable to recover. As a result, the poverty levels rate of poverty may increase over a period of time because of frequent floods and cyclones. What is vulnerability? Vulnerability is the extent to which an economy or environment is unable to cope up with the negative impacts of climate change variability and extremes. So vulnerability is the situation where we are unable to cope up with the negative impacts of climate change. So we are in this phase. So we are not in a position to cope up with the climate change. So already you know that many might have discussed about the impact of climate change on Indian economy. I don't want to spend more time on that one, but still I just highlight. There are several sectors which are being affected due to many sectors of the economy are affected. Economy has three sectors basically: agriculture, industry and service sector. All the sectors are being affected, but more vulnerable is the agriculture sector. Many regions, especially the northern regions and coastal zones, have been affected. Millions of people are affected with increasing number of cyclones, high precipitation, floods, severe and forest fires, acute shortage of drinking water, destruction of social and economic infrastructure, which are common. So more extreme heat, more heavy precipitation, more frequent droughts, faster sea level rise and greater loss of species and ecosystem. So agriculture productivity, it is predicted that 60% of Indian households still depend substantially on agriculture, with 82% of farmers having small and marginal plots. And it is predicted that 25% fall in farm income in some areas due to impacts of climate change. On the other hand, government wants to double the farmers' income, but this is the vulnerability the Indian agriculture is facing. So rainfall patterns have drastically changed. If you look at Karnataka has completely failed in getting the monsoon rain. So almost out of 240 talukas, 190 talukas are facing drought situation. So higher temperatures in various parts of India, especially in Rajasthan, UP and other parts of India, that will impact the health and also economy. So sea level rise and submergence of coastal lands are common, and almost all the cities are submerged nowadays. So that may be due to many other reasons also, but frequent cyclones are one of the reasons for several floods. So this trend spells catastrophe for the economic development and well-being of the millions of people, because 48% of the people are poor in India. So the economic cost of climate change is estimated around 3 to 10% of the GDP. Especially India's 40% poor people, particularly vulnerable communities, continue to suffer the impact of climate change with their limited economic resilience. So the poverty reduction programs continue to fail due to frequent onslaught of the natural disasters like Amphan, as cyclone, which probably push millions of people under poverty line and further raise the income inequality. So if you look at the latest Environmental Performance Index 2022, rethinking ranking country performance on sustainability issues. So this report has taken three important sectors. One is climate change, 30% weightage in the index has been given, 20% weightage for environmental health, and ecosystem vitality 42%. So ecosystem vitality including biodiversity, ecosystem services, fisheries, acid, etc. So environmental health including air quality, sanitation and drinking water and others. Climate change is climate change mitigation, and these are the CO2 and other gases, how they are being mitigated. So if you look at this table, you may be astonished. Where is our country? The ranking is out of 100. This is the score. The highest score is this one. The lowest score is 18.9. India stands here. That is 180 country. So India has neglected its environment and natural resources, and this is the implications of many economic policies. So what EPI indicates? So India has low EPI score, that indicates that the need for sustainability of ecosystem with a high priority focus on critical issues such as air and water quality, biodiversity and climate change. Environmental sustainability cannot be sacrificed for economic security alone, or vice versa. Both are very important. So environmental economists, we have been informing the policymakers on the cost of environmental risk and benefits of reducing them. Further, the cost of risk and their mitigation are increasing. So this will have economic and environmental distributional or equity effects. So we have also policies on the other hand, such as sustainable developmental goals like no poverty by 2030, zero hunger, and many towering goals are there, but they cannot be achieved simply because policies are laid down. So now let us come to the policies, how government of India is addressing the climate policies. So India's long-term low-carbon development policy, India has submitted UNFCCC its first nationally determined contribution under Paris Agreement in August 22, last year. So submission of the intended nationally determined contribution is mandated as per the Article 4, Paragraph 9 of the Paris Agreement. It states that each party shall communicate a nationally determined contribution every 5 years. So COP26, in that India has committed at COP26 to achieve net zero carbon dioxide emission by 2070, and it is anticipation of $1 trillion climate finance from developed countries, which are far from removed from reality in the absence of timely transfer of technology and adequate international climate finance for mitigation and adaptation. Even though India has announced its climate policy of net zero carbon dioxide emission by 2070, but India lacks finance, transfer of technology, and also other adequate international climate finance. So this is the main drawback to achieve the target by 2070. So the world has missed many targets in the past, and India's resolve to achieve the climate target entails a highly challenging position to reduce 2,533 million tons of CO2 emission to zero by 2070. Or net zero means the whatever carbon which is emitted, that should be absorbed by the system itself, like forest sector. So in fact, India's global share of CO2 emission has increased from 3% in 2000 to 7% in 2016, with the annual average growth rate of 4.7%. In fact, India's emission, carbon dioxide emission, is increasing over a period of time because of economic activities. So India is embroiled in one of the biggest policy challenge, as I mentioned earlier, in the 21st century, realizing the twin goals which are vertically at loggerheads: economic development and climate change. So these are some of the other long-term low carbon development policy. They are also very interesting, and you can observe. These are the policies. So this one is to put forward and further propagate a healthy and sustainable way of living based on traditions and values of conservation and moderation, including through a mass movement for lifestyle changes for environment as a key to combating climate change. This is the one policy. Then to adopt a climate friendly and cleaner path than the one followed hitherto by others at corresponding level of economic development, to reduce emissions intensity of its GDP by 45% by 2030 from 2005 levels, to achieve about 50% cumulative electric power installed capacity from non-fossil fuel based energy resources by 2030, with the help of transfer of technology and low cost international finance, including Green Climate Fund, to create additional carbon sink of 2.5 to 3 billion tons of CO2 equivalent through additional forests and tree cover, to better adapt to climate change by enhancing investment in development programs in sectors vulnerable to climate change, particularly agriculture, water resources, Himalayan region, coastal regions, health and disaster management, to mobilize domestic and new and additional funds from developed countries to implement the above mitigation and adaptation actions in view of the resource required and resource gap. Last one, to build capacities, create domestic framework and international architecture for quick diffusion of cutting-edge climate technology in India, and for joint collaborative research and development for such future technologies. So these are the 8 important long-term low carbon development policies India has announced and also committed to Paris Agreement. Further, if you look at the Bonn Challenge in 2011, is an important global effort to bring 150 million hectares of world's deforested and degraded land into restoration by 2020 and 350 million hectares by 2030. This is another commitment Government of India and world countries have committed. So as part of this international effort, the Government of India also pledged to restore forest landscape target of 13 million hectares of degraded land by 2020 and 21 million hectares by 2030. So if you look at these policies critically, one can find these answers. In 2021, the total forest and tree cover in India is 80.9 million hectares, which is 24.62% of the geographical area of the country. As part of this international effort, Government of India also pledged to restore forest landscape target of 13 million of degraded land by 2020 and 21 million hectare by 2030, total 34 million hectares. So if you count both, 20.9 plus 34 million hectare is equal to 114.9, 150. So India's total geographical area is 328.7 million hectares. If the forest cover increased to total 115, the total area under forest cover will be 34.95%, that is 35%. It is more than 10% of the total geographical area should come under forest and trees. But the challenge is that where we find such land to afforest. So the Barn challenge is an important global effort to bring 150 million hectares, out of which the India wants to commit 150. The world's for deforested and degraded land into restoration by this one, 500 million. India commits to 22.98% of the global commitment. But India shares only 2.4% of the total geographical area of the world. So what is the innovative financing approaches government of India adapted to bring 10% of the geographical area under forest landscape restoration is clearly not known. If you look at the change in forest dynamics, apart from the agriculture is being affected, the climate change is also affecting the forest. Especially the dense forest and evergreen forest are turned into dry deciduous forest and like that. So analyzing per capita per hectare carbon stock in different forest type, it has been found that tropical wet evergreen forest has maximum per hectare carbon stock, that is 157.18 tons, followed by Himalayan dry temperate forest and Himalayan moist temperate forest and subalpine forest, like that. There are various forest types you can find. Forest is not the same, but the forest also types also matter for the carbon sink. And the carbon sink of 2.5 to 3 billion tons are expected from these forests. And if you look at the land use change pattern of India over a period of time, you look at this very interesting data. Total geographical area remaining the same. Forest area has been steadily increasing. How can the forest area increase all of a sudden to 24.25% now? Because the definition of forest has been changed over a period of time. Especially now the forest definition is that not only the virgin forest, but most importantly the agroforestry. The agriculture forestry is also being, all the tree covers are also being included. As a result, the forest area has been increasing. On the other hand, the barren land has been declined sorry, what went wrong? Okay, let me, yeah, it has come, thank you. So the barren land has been declining and non-agricultural land has been increasing, especially housing and industry and roads, etc. Cultivable wasteland has been declining. Permanent pastures have been increasing. Other fallow land has been reducing. Current fallows is 4.68. Net sown area has been increasing. Gross cropped area is also increased. But the contrasting results have been arriving, especially if you look at the India ISRO report, land degradation in India. Almost 30% of India's land area is under desertification. This is the land degradation map for 2018-19. According to the Desertification and Land Degradation Atlas India published by the Indian Space Research Organization, Indian states have recorded an increase in degraded land in the past 15 years. Most land degradation is in the biodiversity rich northeastern states. And this desertification can also be seen and degradation also we can, wind erosion in the case of Rajasthan and others, water erosion in case of Chhattisgarh and other places, and waterlogging in Bihar and other parts, salination in Uttar Pradesh, barren and rocky stones. And the southern states are also facing severe environmental degradation in terms of salinization, water erosion, etc. So apart from that, the government of India is also having several national action plan on climate change. These including National Solar Mission and National Mission for Energy, Enhanced Energy Efficiency, National Mission on Sustainable Habitat, Water Mission, and Sustaining the Himalayan Ecosystem, and Greening India, Sustainable Agriculture, and National Mission on Strategic Knowledge for Climate Change, etc. So if you look at these programs, they are into two categories. One is mitigation, another one is adaptation. So mitigation, as you know, climate change helps in reducing carbon footprints or emissions of greenhouse gases and prevents the planet from warming up. So the reducing greenhouse gases sources such as burning fossil fuels. Yeah. Yes, madam, I'll try to finish. Yes. So reducing greenhouse gases sources as burning fossil fuels for electricity generation, heat, transportation, and such as adaptation requires change in the behavior of human and ecosystem, economic system. Adaptation measures involves change in production and consumption patterns such as environmental friendly industrial and agriculture production and consumption pattern. So these are some of the green initiatives government of India has taken in various sectors. This is power, industry, and residential, agriculture, and transport sector. These are the programs, and this can be, it is also bringing various economic instruments, especially carbon credits, property rights, market creation. The government tries to use all these instruments, but I have a project where I am analyzing the divergence and convergence of environmental and economic policies, where I try to understand there is a still gap between these economic and environmental policies because they don't match each other. And the carbon credits, they have a clean development mechanism, emission trading, and joint implementation, etc. But these programs, they have their own limitations, and their success is very limited. And financing is the major issue in terms of mitigation and adaptation in India. Even though India has committed to the Paris Agreement, 2020 climate goals state that the country will reduce 33 to 35% reduction in the emission intensity, but India wants to increase the forest cover, reducing CO2. However, deficit climate finance may limit the realizing these climate targets. So as per the estimates of India's national contribution, so 137,000 crores required to achieve all these things. That it means that $21 billion during 2018. So the institutional financing policy towards mitigation and adaptation of climate change remains a challenge given the poor financial resources made available in India. Most of the funds are targeted to achieve energy efficiency, investment on renewable energy and sustainable transport, but afforestation and adaptation receive a raw deal. So therefore, the challenge before government is to mobilize financial resources for mitigation of the greenhouse gas by 2030 and financing adaptation activities. So the confluence of conference of the parties COP27 of the UNEP in Egypt earnestly deliberated on elusive issues of sources of funding for climate mitigation and adaptation. This is one of the contentious issues which obviously divide the global north and south climate commitments. So Global South bargains the consistent opinion that timely and effective implementation of climate commitments entirely depends on financial flow and technology transfer from developed countries, whereas the Global North commits ambiguously $100 billion, but it is not coming. This green climate finance is also in the infancy, and the flow of finance is not up to the mark. And even I have analyzed the financing of climate change. So as per the climate policy initiative, the major issue is that the geographical distribution of finance shows that developed countries source their finance from private, whereas developing countries rely on public sources. Even today, in developing countries in India, mainly the governments are investing on the climate finance, but in case of developed countries, the private sector is coming forward. So this clearly indicates grave situation of global governance failure of climate financing in the world, and India in particular. And if you look at the some of the issues, climate change affects everyone. However, the economic development benefits a few due to unequal distribution of income and benefits of development. Further, the climate change imposes high social cost on the society in terms of health, and industries and corporate companies which cause climate change hardly spend on mitigation of climate change. This reflects the situation of privatizing the profits and universalizing or socializing the pollution or the losses. This also shows that appropriation of global commons climate by a few rich business tycoons. In other words, the cost of climate change is borne by government and profits are appropriated by the business. This reminds the grim situation of financing of climate change predominantly by the government and hardly by the private sector, which makes huge profit by appropriating environmental resources and polluting ecosystem services. So this policy approach towards mitigation and adaptation of climate change remains a challenge given the poor financial resources made available at the global and regional level. So some of the policy related write-up I have published for the policymakers. This includes the paradox of global financing of climate change. Our growth path is environmentally unsustainable, and the shadow of poverty on India's climate goals, and balance, we need to balance economic and environmental policies to achieve sustainable development, and GDP debates ignores widespread poverty and inequality, and we need to restructure the economy to bring down pollution, and the environmental policy goals should be, especially for life, we need to bring several policy changes, especially we need to given a proper direction to capitalism, then only we can achieve the life goal. And yesterday I published this one, net zero emission goals are largely unattainable. So these are some of the effort. You can also refer to this, last month it has been published, the framework for climate change mitigation in India, published by IMF. You can refer to this website link. And there is also government recently, 13th October 2023, announced green credit schemes for various sectors, but still the rules have not been framed. Let us see, hope for the best. I can't be very pessimistic, but sometimes optimistic. But this is the stark reality I have opened up for discussion. Thank you, one and all.
Thank you so much, sir. So, Dr. Krishnaraj has spoken on mitigation of climate change, green initiatives in India. In his almost 55 minutes talk, he has covered different aspects from policy issues, then energy consumption, then greenhouse gas emissions, and contribution of climate change from different sectors, including the agriculture, and also how natural nature can be used to reduce the climate change. Along with that, economic activities which are contributing significantly for the climate change. So apart from that, we need to think about the integration of agriculture activities with the industries, as well as looking back to the traditional cropping pattern, altering the cropping pattern, even modifying or diversifying the diets, and taking care of the health of soil as well as the nature and individual's health. So different aspects he has covered, and also at the end he has touched upon the different mitigation strategies. So with this has given a wonderful talk on that. Thank you so much. Now the forum is open for question answers as well as the discussion. students are?
I think they didn't like my lecture.
No, no.
It's been very exhaustive and I'm sure they are very much benefited.
Okay.
No,
Because I
at the
am
end.
from economics background, no, there may be some.
No, we need money for everything.
Yes, that's true.
We need economics, ultimately the liquid thing. So without money, I think we can't live. Even to buy the gadgets, because we have to integrate even the IT industry or IT sector to mitigate the climate change. Because climate change is being happening since inception. But now we are realizing, thanks to the media, in fact, at least now it's a good time. We have so many young minds who can definitely take up different initiatives, because you think slightly different than usually youngsters think out of box than the traditional way we all think. Probably they will go through, they will read, because it needs economic aspects. Really require a lot of time.
Actually, the basis of.
Yes.
Yes.
Yeah.
And maybe we can, some of the case studies where all these, when we make this problem statement, few good examples where people have addressed all these. If it is added, it may motivate.
Yeah, I talked from the global perspective, macro perspective. I can add that one. But more importantly, from the policy perspective, there are success stories. I do agree.
No,
But-
many industries have now been given the
Yes,
choice to.
Yes, yes.
Here, just to the notice of the youngsters, I just want to share a small example, because that girl is also recently she has received a Young Leader Award, mainly for climate change. Her initiation is half glass full.
Yeah.
Yeah, half glass full. She's one of my close friends' daughter. Garima is her name. You can just Google and see. Whenever we go to restaurants and all, they allow them to pour the water to complete glass, and we drink just 20-25 ml or 50 ml. That's how we, spoil the water ecosystem. But this girl has started the initiation of, saying the half glass full. So let them serve only the half glass. Let us drink that half glass. Then we can ask the waiter or the person to serve another half glass. So that's one of the initiatives. And recently I have read another story of a farmer from Maharashtra. They have used water resource management by putting the mud pots into their land. So the rainwater during the rainy season, it will be deposited in the mud pots, and during the off seasons like summer and all, it will be naturally drained down to the soil, and that's how soil organic carbon is enhanced. So like that, I think probably some successful stories or case studies.
I would like to add one thing.
Yes.
So I do work on Bengaluru city urban water supply and demand management. So one of my studies has resulted in finding, one of the findings is that nearly 48% of the water we receive from the river Kaveri is being wasted. Half of the water is being wasted. So why that is wasted? Because of leakages, theft, and other reasons. So this is how we are wasting the scarce resources, that too having interstate water disputes. So we need to attach more importance and behavioral changes towards water. So even I went to New York City, and I have done a comparative study between New York and Bengaluru City in the context of climate change, how their policies are addressing. So their policies are not bringing the water and wasting it. They are reducing the water usage by the implementation of policy of demand management, demand side management. Whereas in case of India, we are still in the supply side management. Wherever there is water problem, we bring the water. After that, we don't know how we spend it or we use it. So as a result, the government of Karnataka has announced 2 crores for BEWSSB to find out where the water is flowing, or theft is taking place, or leakage is taking place. You might have seen UFW, where the L&T has dug up and it is still finding. We don't know where water is going in. In Bengaluru City.
They have already gone deep enough with borewells.
Yes,
They
yes.
won't find water that's
Yeah,
easy.
most of the water, sterilized water you drink, they are from the theft water only.
No, I think what's most important is the lifestyle changes
Yes, yes.
towards behavioral economics.
Economics. Yes.
These are the two aspects
Yeah.
which need to be covered.
I hope students are having any questions. Probably they can have interaction during
One
the
or two maybe
tea break.
entertained if they have questions. Otherwise, yeah.
Yeah, you can interact during tea break. Sir is available. So as you told, economy is very important. Water economy. Actually, in other states, I heard water for utilization, for drinking purpose, even for the household purpose, they are metering in their this one. But in Karnataka, yet to come. That is very important aspect. People are debating on this.
95% meeting is there, but the
Still, yeah, that's true, madam. That's
one
true.
thing, meter does not work. But there are two connections. One meter connection, another one is
Unmetered connection. Thank you very much, sir, for your interesting lecture. And I request our Katre Shakuntala madam, please present a plant and certificate appreciation to the speakers and also co-chair and co-chair this session.
My chairs are wonderful.
Thank you, Usha Ravindra madam, for chairing this session. I request madam to present. Madam, please. Plant certificate of appreciation. Thank you, Vijay Kumar sir, for co-chairing this session. I request madam to present a plant and certificate of appreciation. Now we have 10 minutes quick tea break. After that, we can start next session. Thank you, one and all.
ಕೇಳಿಸ್ತಿದ್ಯಾ 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 ಪರ್ಫೆಕ್ಟು ಓಕೆ ಪರವಾಗಿಲ್ಲ ನೀವೇನೇ ಫುಡ್ ತಿಂದ್ರೂ ಔಟ್ಸೈಡ್ ತಿನ್ನಬೇಕು. ಯಾಕೆ ಅಂತಂದರೆ ಇರುವೆ ಸೀರಿಯಸ್ಲಿ ಆ್ಯಕ್ಚುಲಿ ನೀವೇನಾದರೂ ನೀವು ಲಾಸ್ಟಲ್ಲಿ ಕ್ಲೀನಿಂಗ್ ಮಾಡೋರು ನಮ್ಗೆ ತೋರಿಸ್ತಾರೆ ಎಷ್ಟು ಕಸ ತಿಂದು ಅದೇ ಚಿಪ್ಸು ತಿನ್ನಿ, ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ, ಔಟ್ಸೈಡ್ ತಿನ್ನಿ, ಇಲ್ಲಿ ಬನ್ನಿ. ರೀಸನ್ ಏನಂತ ಹೇಳ್ತೀನಿ, ಇರುವೆಗಳು ಆ್ಯಕ್ಚುಲಿ ಇಲ್ಲೊಂದು ಓದು 2-3 ವರ್ಕ್ಶಾಪ್ ಬ್ಯಾಕ್ ಇಲ್ಲಿ ಇರುವೆಗಳು ಎಷ್ಟು ಮುತ್ಕೊಂಡಿತ್ತು ಗೊತ್ತಾ, ಸೀರಿಯಸ್ ಆಗಿ ಇಲ್ಲಿ ಪೋಡಿಯಮಲ್ಲಿ ಸ್ಮೆಲ್ಗೆ ಬರ್ತಾವು. ಔಟ್ಸೈಡ್ ತಿನ್ಕೊಂಬನ್ನಿ, ಅಲ್ಲೇ ಡಸ್ಟ್ಬಿನ್ ಇದೆ, ನಮ್ಮದೇನು ಅಭ್ಯಂತರ ಇಲ್ಲ.
Good afternoon to one and all. I request today's speaker, Sebastian Peter sir, please come on to the dais. And I request today's chair of the session, Dr. Ramakrishna Reddy sir, please come on to the stage. And Professor Jayashree madam, please. Co-chair of this session, please. Welcome back. So we have today Professor Jayashree as a co-chair, Madam has academic qualification MSc, MPhil, PhD, B.Ed and NTT, and has been serving MS Ramaya College and Arts, Science and Commerce College from 1999 till date at the Department of Biotechnology and Genetics. Madam has published more than 20 papers at national and international journals of repute. And Madam also participated in national and international conferences at Borneo Island, USA and China that regained Best Paper Session Award at Johns Hopkins University, Washington, USA. Madam has been working as at NGO at Friends of Lakes and others environmental committees. Madam is always associated with KSTA. Thank you, Madam, for co-chairing this session. I request you to please introduce today's session chair, Professor Ramakrishna Reddy sir.
Good afternoon to one and all. It's my honor to introduce chairperson of the session, Professor K. Ramakrishna Reddy. Sir has teaching experience in both research as well as in teaching around more than 45 years. He has an academic qualification, like he got his master's at MSc at Gulbarga University in 1991, MPhil Gulbarga University in 1992, PhD Bangalore University in 2009. Sir has a very good position as Controller of Examination, Government Science College, Principal, Government Science College, Registrar, Bangalore University, Registrar Evaluation, Rapatunga University, Regional Joint Director, and many more. Sir has been successfully guided MPhil and PhD research scholars. He has an academic responsibilities such as moderator, membrane state level expert committee, UGC expert committee member, IQAC coordinator, state coordinator, chief custodian, external expert committee, committee member, HOD Department of Chemistry, coordinator PG program, NAC steering committee, convener, member of board of studies as BOE, BOS and BOAE in chemistry. So has membership in various professional bodies, like is a life member in many academics like KSTA, KAS, ACCCA and many more as a member for Chemistry Teachers Forum, Bangalore University, Bangalore. And is a government nominee in governing bodies, academic councils, syndicate meetings, and has organized various seminars and workshops at state levels. So has completed major research programs on synthesis, characterization and formological studies of Einstein Schiff bases and their metallitic complexes in January 2001, UGC New Delhi, and has an amount of 11 lakhs. Establishing the Faculty for Studies on Electrochemical Energy Storage Devices using electrodes incorporating metal oxide nanoparticles worth around 20 lakhs at VGST, Government of Karnataka. Sir has various research publications and has patent and also has authorized many books. Sir has participated and presented papers in seminar, conferences, workshops, around 45 at national level and around 9 at international level. And he has patented on the title of the invention, preparation of 3,3-TM-D1A adamantly 4,4-TM dimethoxy 1,1-TM biphenyl, and has been published in the year 2020. And so as book authorized on engineering chemistry. compendious practical organic chemistry, advanced practical organic chemistry, and he has an invited speaker in many organizations. Thank you, and thank you, sir. Welcome.
Good morning to all of you. Thank you, madam, for your kind words. I basically a teacher, a lecturer in a government college. I started my career as a lecturer in 1992. Till last 4 months I was teaching in a degree college, both for UG programs and PG programs. I thank KSTA for inviting me to chair this session. Now it is my pleasure to introduce today's speaker, Dr. Sebastian C. Peter. Before that, I want to tell a few words. I worked in Government Science College for more than 13 years, and we have a long association with both KSTA and also JNCASR. We used to invite faculties from JNCASR to deliver lectures in Government Science College. We have collaborations, thanks both for KSTA and also JNCASR. And recently I received a letter from CEO, Professor Dr. Ramesh, that you are organizing a program like this. If he requested me to put a letter to different government colleges and AD colleges to participate in this program. I don't know how many of students or faculty from degree colleges and PG colleges come for this. Therefore, I happily, wrote a letter to all colleges to participate for this kind of programs. And I would congratulate all the participants because it's a big opportunity for you to interact with the stalwarts because they're experts in those fields. They will give the glimpses to you. Therefore, and one more thing what happens is, the speakers got introduced to you, therefore you can think of different institutions, different scientists. It's an opportunity for you. I congratulate you all people. Now, the speaker, Professor Dr. Sebastian C. Peter, he received his MSc from St. Thomas College, Thrissur, Calcutta University in 2010. Then he did his MTech in 2002 from Cochin University of Science and Technology. And he received his PhD in chemistry from University of Münster, Germany in 2006. And he was the postdoctoral fellow at the Max Planck Institute for Chemical Physics of Solids, Dresden, Germany between 2006 and 2007, and Northern West University, USA between 2007 and 10. Dr. Peter joined as a faculty fellow at New Chemistry Unit, JNCASR, Bangalore in 2010. His broad research interests include the development of solid-state inorganic materials for various applications, ranging fuel cell, CO2 reduction, and in condensed matter physics. He has more than 210 peer-reviewed publications and 5 patents. He was invited and attended around 100 national and international conferences. He is the recipient of Young Investigate Award from ACS. Please give a big applause. In 2013, RSC in 2017, and IOP in 2016. He was awarded Ramanujan Fellowship in 2010, MSRI Medal in 2010, Swarna Jayanti Fellowship in the category of Chemical Sciences in 2018, CRSI Medal in 2020, SMC Medal in 2022, and IAM Fellow in 2022. Big applause to sir. He is a member of American Chemical Society, Royal Society of Chemistry, ASM International, Chemical Research Society of India, Material Research Society of India, International Union of Crystallography, Indian National Young Academy of Sciences, and Society of Material Chemistry in India. He is the founder and director of the startup Brite Applied Sciences Private Limited and entered into final round of NRG Kosia X prize 20 million USD prize on waste CO2 utilization. His team is the only one team in final round of competition, earning $500,000 USD as milestone prize. Breathe Applied Sciences Private Limited has been selected as one of the best 100 startups by Karnataka government in 2017 through Elevate 100. Clean Equity Monaco 2019 selected carbon dioxide reduction technology at the second best in the global level. His team scaled up the technology CO2 to methanol from the lab to pilot level with a capacity of 300 kg CO2 per day. In 2021, Technology Development Board of the DST awarded National Technology Award for his development. In December 2021, his startup has been selected as the winner of the KMPG Enrich 21 on the theme The Global Corporation Preparation for the Low Carbon World. He also received National Prize on CO2 reduction and Green Hydrogen Production instituted by CNR Rao Foundation and ETU of JNCASR in 2022. Dr. Peter also featured in the 75 under 50 Scientists Shaping Today India by DST and selected for JC Bose Diamond Jubilee Lecture Award IAM. In 2023, Dr. Peter led Breathe to win the competition Materials Next 4.0 hosted by Tata Steel. Dr. Peter received Research Partnership and Industry Translation Medal from Chirantan Rasayan Samstha and Material Science Annual Prize from MRSI in 2023. Now, sir is invited to give a lecture to you. His experience, his what I can say, his work, going to present in front of you. You should take the benefit of that and you should inspire after the lecture and there should be wonderful discussions after the lecture also. Welcome. Sir, thank you so much for accepting the invitation of ASTA to give lecture in front of these participants. Thank you, sir. Over to you, sir.
Thank you very much for your kind introduction. I am overwhelmed with the detailed detail one. It took actually almost 10 minutes, looks like. Thank you very much. First of all, I would like to thank KSTA. I think you can see. Yeah, that would be nice. You know what is the physics that one? 2 mics? What is the physics? So when somebody is giving a talk, you should not carry mobile in your pocket. So if you get a message, I should move ahead. Yeah. Okay, so first of all, I would like to thank KSTA and Dr. Ramesh for inviting me, and I'm very happy to be here. And this is only 8 kilometers from our institute, not far. I mean, I can come by two-wheeler also. It's very easy to come. But first time I'm coming here. It's a surprise. Happy to see you all. And first of all, I would like to start by saying I'm a chemist. I'm a material scientist. And I don't know how many of you are chemists. Can you raise the hand, please? But the students, how many are chemists? Chemistry at least is some in bachelor, MSc. Okay. Otherwise I have to go down a little bit, to make you, comfortable so on. Because, sometimes if I go, beyond that when you start to sleep, that's not good for me as a speaker. So, basically I'm a chemist, I'm a material scientist. So, my talk actually built in such a way, the problems, you all know this problem, the problem that associate with the CO2, carbon dioxide. From childhood onwards, even my kids, they are only 11 years old. They started to understand what is CO2 at the age of maybe 6, 7. They know that. Nowadays in the books and all they are talking about. And we just finished our World Cup mania. Just finished. It's very unfortunate we lost in the final. But before that, 1 week back, there was a news. The team, Bangladesh team, they cancelled their
practice in Delhi because of air pollution, right? And that is associated with CO2. The amount of CO2 that actually emitted, and automatically the air pollution, what you call index, we call it as, and we cannot stay. If you just go to the city, Bangalore, you just go to city and come back by evening, you will get a headache. You just stay sometime outside, you feel that one headache. It can be due to the sunlight, it can be due to, you are not eating food, maybe you are not drinking water. But apart that, you are also exposing to the polluted air. And then there is a quantity level measurement also. Suppose if you have close to 1% of CO2, you will end up in nausea. Okay, I will show the slide, what are the concentrations. So this is a gigantic problem, and all over the world, and if you take any social media, any magazine, any newspaper, any scientific magazine, this problem, the solution, attempts, etc., either by chemists or by geologists or by even by what you call celebrities, they are also working on that one. Everybody actually talking about the pollution associated with CO2, how we can tackle it. And as a scientist, as a poor scientist, I have only small percentage to contribute that one. And that's what I'm going to talk here. I just mentioned this is a carbon recycling, okay? And carbon is not a problem. Carbon we need. If you look at carbon dioxide plants, they need carbon. And we cannot eliminate completely. We need to have an optimized amount of carbon dioxide. The moment it is going up, it's a problem. So in this talk, I will talk about a journey that we had. But I will address the issues, because I have to address the common people, how this problem. Now the question I just put on to the public. Are you responsible? All of you are responsible. Suppose you can say, no, I'm not driving any car. I'm not cooking at home. Still, are you responsible? Yes, right? Okay, you just sit at home and you are not going anywhere. Are you responsible? How? Oh, that is. No, that is natural. Beyond natural. Okay, I just use candle. I just use. Yeah. True. Yeah, I just want to go to a Dravidian culture. Okay, so just eat food without cooking. Yeah. Okay, but we cannot go back. We have to live with that technology development. We have to move forward. So we have to move forward. Whatever the development in terms of industrial or even urbanization, we have to accept it. But the problem associated with that issue, we have to tackle with other solutions. Okay. So we use, WhatsApp every day morning, hi, hello, how are you, etc. And we post that one, right? And one hi is equal to one CO2, if I put it. One hi equal to one CO2. How? At the end of the day, you have to charge your mobile. Depends on how extensive you use that one, you are charging the mobile by using the electricity, as sir correctly mentioned. So there's electricity is coming from coal power. So basically, depends on the amount of any electrical items what we are using, we are responsible for. So we have a certain carbon credit. Depends on how much you are using actually carbon credit. And our population is actually #1 in the world. Right? And we are responsible. Most of us, we don't understand the impact of that one. Over a period of time, it is actually an issue. If you look at this figure, okay, and you can see that any item, whatever you are using, whether your cloth, your pen or pencil, shoe, whatever items, that can be produced from oil, right? It can produce, you can talk about, okay, my cloth can be from Gadi. But most of us are using actually, synthetic also, right? So it is actually dominated with the resources available that we process with a different technique, and over a period of time, many things happen. Or if you talk about energy, the figure is 2015, and you can see that the projection of energy requirement in terms of quadrillion British thermal units, you can see that the demand is going up. At that time it's projected as this one, but it is going this way. So the demand of energy is going, and then in whatever the resources we have available, we are using, and over a period of time we are looking for renewable energy, but we are not well equipped with the technology to translate completely to the renewable energy. For example, hydrogen. Hydrogen, everybody is talking about hydrogen. Well, by 2050 we are going to be hydrogen, but the problem is actually hydrogen is producing from green hydrogen. If you are talking about hydrogen, can be produced from water. You know the ground reality. The average, the total population contribution actually from India 17%, but our groundwater available only 4%. And you look at Bangalore, particularly north part of Bangalore, there is a shortage of water. Okay, and we have to produce hydrogen from water. We cannot use hydrogen. We cannot produce from hydrogen, from seawater, because the technology is still not yet matured. Wastewater, another problem. How we can use this 4% water for hydrogen, this is still a mystery. And on the top of that one, this groundwater, we have to do the demineralization. Like in the water purification, we do it at home. 30% only water can be purified. The rest you are actually dump it outside. So we don't have the resources available for the hydrogen. So it's a long, long way to go. Okay, still we have to use the natural resources. All this process, these reactions, chemistry is happening. Use coal and burn it, produce electricity, this much electricity, and you get 1 mole of CO2. Or use methane, and you get this one. Or use heavy hydrocarbons like petrol, diesel, and beyond that one. You get see that one around 8 mole of CO2. Okay, and you drive a car, say for example 10,000 kilometers, approximately 7,000 kilograms of CO2 you are dumping to the atmosphere. One car. And this room, or those who are having car, just imagine in Bangalore city how many kilograms of CO2 dumping to the city. It's huge. And everybody's house, if you check the odometer of car, approximately 40, 50, 60, 70, depends on the age of the car, depends on the way, you are using. Okay, I'm only talking about automobile. Okay, just go to the development. You are seeing that metro construction is going on. You need cement and steel. The most amount of CO2 that is producing actually from cement and steel. Okay, and if you look at the aerial map of, I'm only talking about Bangalore city, talking about that one. Earlier it was a green nature, 25, 30 years. If you look, talk to the old people, they will tell that one, even for summer you have to come with a jacket because it was a kind of a AC condition. Now you don't need it. Okay, and you are completely developed. It's good. It's good and nothing wrong in that one. But the solution is not there. Solution is not at the matured. And these are the sources. Stationary sources, like you can see the list here, or mobile sources, I already mentioned, and this is a natural sources. And nature is such a way, all these sources, nature can take care about themselves. But unfortunately, the man-made, human-made, technology-made, what we call as anthropogenic CO2, we don't have the solution. We try to capture, sequestration, store it, etc., etc., but the amount of CO2 is actually producing, we don't have the capacity to store, unfortunately. It's a difficult task. And if you look at this, so last 1 century or beyond 1 century, you can see that the temperature is rising because the ppm level, it started from something around 300 and it reaches here. You can see that over a period of time, 400. The current scenario, if you look at that, as of last week, 418, and you can see that 418.84 ppm. And the temperature, global temperature, average global temperature is increased by approximately 1 degree. Depends on the locations, it can be here and there. Okay, and you can check the website here. And there is a observatory in Hawaii, and every day they update. The second decimal is actually increasing. The only time that went down during the COVID time. At that time, all the industry shut down, automobile shut down, and everybody sitting at home. So automatically there was a drop, and we cannot, shut down ourselves. It's not good. It doesn't look nice. Okay, so I just bring, probably you heard talk of Professor Bala from IAC. He was a part of in the committee, IPCC, and International Panel on Climate Change. You can see that, and this is a big report. Every year you can read it. If you are interested students, I recommend to read that one. You will understand the problem associated with them and CO2 in depth. You see this shaded area, they proposed, projected. This shaded area is going to be underwater by 2050 if we are not taking proper action. Okay, so you know that a billion people in the country, million people at the seashore, and most of them, say for example Mumbai city or Kolkata or Chennai, majority of the population, and many people actually surviving their life, their daily life at the seashore. Okay, all are going to be underwater if you are not going to take a proper attention. That's what their projection. And there are a lot of information. Say for example, 3 years or 4 years or 5 years before, 1 kilogram of sear fish, if somebody likes sear fish, so the price was half or less than half. And the price of sear fish is gone very high. I'm talking about the marine food. And then the reason is actually if you want to fish a good fish, you have to go to the deep sea. The fish at the seashore, it's actually poison. And you will end up in actually, health issue. And if you look at carefully at the eye of fish, you will see some green color. Sometimes you see a green color. And that is actually, dangerous. You can see that one. Some of the preservation also they do that one. But beyond that one, at the seashore, it is not. The reason is actually, this actually changed the pH of the water. Okay, it is not, it's a good water. Anyway, so you can get a lot of information. Yeah, here you go. If you look at that one, there are a lot of strategic plan injecting CO2 to the ocean, or at this one, can see that at the soil. There is a limitation. Number one, as per the current scenario, our government is not recommending because we need a large area for the sequestration, and we don't have that much space to accommodate. Geographically, we are restricted to that one. Not only that one, if you do that, the pH of the soil will be changed, and then our agriculture can be an issue. All this, everything, you can talk about, it can be a dramatic changes. So government is not really, serious about this one. If you are going for the marine one or sea one, sequestration, it will change the pH of that one. CO2 plus water, if react, it will form bicarbonate. So automatically, it will change the pH of that one. So if you look at this one, volume of CO2 in air, 1%, 3%, 5%, 8%. If it is 1%, you can see that a drowsiness, you get a headache, etc. and all. Okay, so always, you feel that, okay, I was under sun, that's why I got the headache. It's correct actually. What is the chemistry or physics actually, the sunlight. Sunlight has a heat, any idea? Heat is there in sunlight? Is it? If that is the case, if you go to Siberia, you will get a really warm condition. There is sunlight. When it interacts with the matter. If you keep, in a wood and then steel body under the sun, and then, after 1 hour, you go and touch wood and then steel, you feel really hot with the steel because light interacts with the matter. And that actually heat produces. It's exactly happening when you have more amount of CO2 molecule. The global warming, you are talking about CO2 molecule, when it interacts with light, actually it releases heat energy. That's the reason actually if you have more amount of CO2, global warming is happening. So you will have this problem, And you can see that if you go further 3% reduce hearing, you may not, you have the problem with organ. Okay, keep in mind, all organ one by one actually can be damaged with the presence of CO2. Or if you can say mild narcosis, and if you go further, you can say the dizziness, confusion, headache, shorten of breath, and finally if you have more, you may end up in dying. For example, mines and everything, you can see that when some news here and there, because of lack of sufficient oxygen or excess of CO and CO2, people might have died. So this can happen, and over a period of time, slow death also can happen if you are consistently getting excess of CO2. Well, there are a lot of the world leaders came forward, and then they discussed on this matter. For example, the ex-American President, Barack Obama, he mentioned that when all this global warming or issues are because of China and India. And many people criticized. He was correct. He is correct. And because the development happening in these countries. Because of the development, this problem started. And this is exactly, showing the graph per capita CO2 emissions. As I was talking about per capita CO2 emission, India and China, you can see that after 2000, when the globalizations happened, it started China a bit early, but it happened, maybe end of 2000, that time, it started, and you can see that the amount of CO2 in China and India per capita is actually going up. Okay, so no wonder we may cross China also very soon. Okay, so it's good. The country in a good direction, development, everything is fine, but this problem is also associated with that one. And we know this one. I don't have to explain much. You all very familiar with that one. At the end of the day, we have to make such kind of a system. It's extremely hard. Or you can make it as an, this way, instead of, the plant, in addition to plant, we can also make the system. But the problem is actually, we are not able to do because the gigantic emission of carbon dioxide. You can see that this is going up and up and up, and, it's almost, around, I don't know the number, this is a 5.1 gigaton of CO2 per year. It's actually 5.1 gigaton. It is that much huge amount of CO2 is producing, and we don't have the system to store it or capture it or convert it, unfortunately. You can talk about geologists, you can talk about chemists, you can talk about, just whoever is actually, it is a Herculean task at this moment. And there are a lot of terms put forward. You can see that one carbon neutral, that's nothing but carbon emissions equal to carbon removal. Nature is doing that one. Or carbon negative, and you can say that when carbon, remove the carbon from the atmosphere and then sequestration, and later we can do that one, so after 100 years. He introduced X Prize competitions. We were in the final round of that competition. Only one Asian team was in the competition, but the next competition is actually carbon capture by the Tesla owner. So he introduced that 100 crore, 100 million, competition prize. But in that case, after even 100 or 200 years only, you can just dig it out. But we don't have the enough space to accommodate, unfortunately. Okay. Now, net zero. Carbon net zero. So here, what we can do here, whatever CO2 emitting, capturing, and converting to the chemicals and fuels. Okay, we know that we use so many chemicals. The plastic one, ethylene, polyethylene. Okay, this ethylene that we produce in our lab. That ethylene can be polymerized into the polyethylene, but plastic is not good. Plastic also a problem. Or if you can make a polycarbonate, or we can do that isopropanol that we use in the, where we use isopropanol? When COVID happened, we always sanitizer. Okay, major portion is actually isopropanol. Acetone, acetic acid. Acetic acid, where we use? Vinegar. Okay. Or we talk about isobutylene. I hope you heard about this one. The cosmetics, the smell, This nice, beautiful smell is coming from that one. We produce in our lab. So each product has its own niche market. Or you just travel in aeroplane, sustainable aviation fuel, C12 to C18, that also can be produced from CO2. Okay, anything that you can think about, that is currently used and that can be produced from CO2. So if you can do that technology, that is one of the solutions. And our Honorable Prime Minister, every leader, I'm talking about every national leader of this globe, they actually took necessary steps. Okay, so he introduced the term Panchamrit. Okay, just this is a national agenda. Panchamrit is nothing but you can see that reach non-fossil fuel fossil energy capacity of 500 gigawatt by 2030. 50% energy requirements via renewable energy by 2030. 1 billion carbon emissions by 2030. And reduce carbon intensity below 45% by 2030. And India will achieve the target of carbon net zero by 2070. 2070. We are in 2023. Okay. So, to be honest, I am working in this area. It is a tough task. It's extremely tough task. The way we are trying to solve the problem, it is much more than much lesser than the problem that is actually introduced. It is difficult. And you can see in India itself, 1.91 metric ton in 2022. That is actually 5 to 6% more than 2021. This year it may be 2.3, 2.4 it will come. It is increasing. And 2050, different countries, different way. For example, if you go to the Scandinavian countries, they are well developed, not much problem. Okay, they already banned coal. Okay, and they are actually targeting 2040, relatively easier. Okay, and if you go to the small country, this is maybe the size of Karnataka probably, but much developed country. And India is actually 2070. Or different industries, say for example BPCL they proposed 2035, Reliance proposed 2040, and different countries, Tata is also 2040 or 2038, etc. and all. And different industry also proposed net zero by this. And all of you, maybe 2070 and what age you are, I don't know, but it is beyond our generation strategy. So the next, what you call, a generation has to take the baton from the current generation. If you look at me, I will be retired by 2043. Okay, so we cannot do much. It is a massive problem. We need a lot of expertise, not only chemists, and even there are a lot of social activities and activists. Actually, they are working in this area. A lot of policymakers are working in this area. Everybody, they are trying to do their bit. But there are criticism from my side. There are a lot of meetings happening, but activity is not happening. That is also from my concern. But as a scientist, how we have started, I'm a material scientist. I'm a poor material scientist. We started in 2015 only because we understand this problem. Well, after that, we had a exponential growth. Well, there are a lot of R&D areas. Those who are interested, and this is a massive. Go to the certain part of the country. This is a massive one. Agricultural waste, or if you talk about the food waste. Okay, and anything you can think about, and this can be taken care. In fact, in the national committee for this one. But if you go here further, CO2 separation technology. You might have heard about absorption, adsorption, membrane, and other related items. A lot of fundamental science are happening. How we can selectively capture CO2 from a mixture of, say for example, if you have 1% of CO2 in air is having nitrogen, oxygen, CO2. And typically, CO2 in air, it is in the range of 300 to 350 ppm level. And if anything goes beyond that one, selectively can be captured, there are technologies available. It's a mature technology. But from the air, this problem is actually nothing but the amount of CO2 is actually much less. If I talk about, I'm slightly a businessman too, in addition to the scientist, but if you talk about, the cost of CO2 capture from air, it is approximately $500 to $700 per ton. But the moment, if you capture CO2 from coal industry, it is a $40 per ton. So naturally, I mean, businessmen will not put money in the direct air. It's expensive in nature. We cannot do that one. So the government has to come forward, or technology has to build in such a way it should be economical process. So anyway, so here if you go to this one, CO2 capture technology by using bacteria, algae and other related things, we have one of the largest plants of CO2 capture technology in Vizag by HP. They commissioned this plant 3-4 years back. And then this is the area I'm going to talk a bit. And then CO2 disposal technology, you can see that one. Environmental friendly technology, I was talking about hydrogen, or proper catalyst and other related items. So all this kind of the actions can be done to control the CO2 related issues. Now I bring little bit chemistry here. I will take it very simplified. Those who are not understanding, you can ask question at any moment of time. Okay, I am very happy to hear the question. CO2, you might have learned in high school, it is a linear molecule with a C double bond O both sides. Okay, that is a major problem. It is very stable. It is very stable. To activate and then convert into something else, it is an extra bit of energy required. Okay, so it is not easy to convert CO2. Say for example, I want methanol. You know methanol, or I want ethanol. Okay, ethanol is actually produced from sugarcane. Okay, distillations, use that one. But if I want to produce CO2, ethanol from CO2, this guy is not active in nature. I have to make him active. Okay, it is a challenging problem. And don't worry about this figure. This is a thermodynamics, we call it as in chemistry, and in physics also you can say that one. The number says, the number says actually CO or CO2, this kind of products we can make it. Say for example, this is methanol and this is methane, and you can see there are a lot of products here. I only take these two products because of the energy, the fuel that it can be used. Say for example, M15. Anybody heard about M15? No. E10? No. At least E10 is nothing but 10% of ethanol blended with the petroleum. This is the fuel that is used in using in United States and Brazil. This will improve the efficiency and reduce the cost of the fuel. M15 is nothing but 15% of methanol blending with the petroleum. This is introduced by Niti Aayog, Government of India in 2015. Okay, there is another called M100. That's nothing but 100% of methanol. 100% of methanol. There are 20,000 taxi introduced by Chinese government last year in Beijing. Okay, so to reduce the what you call the problem associated with the diesel and petrol, because methanol will produce less amount of CO2 compared to the diesel and petrol. A20, that is actually introduced by Italian government, 5% of ethanol, 15% of methanol, and the rest is actually petroleum. Okay, there are a lot of studies happen. So here, if you want to have methanol, the problem is actually there is a change in oxidation state from CO2 to methanol. To have that one, you have to apply temperature and pressure and plus catalyst. Okay, there will be an energy barrier for a reaction from CO2 to methanol, that you need a temperature to apply. That temperature is also coming from in the form of electrical energy, right? So there is energy input associated with that one. It is actually a problem in a cycle. Okay, so then how to get that energy? There is additional headache. So because of this reason, it is still not an economical process. On the other hand, if you want to make a carbonate, it is an easy process, you don't have to worry. So it depends on the product you are looking for, it can be an issue. The chemistry says that thermodynamically you are restricted to convert CO2 to any chemical. The language is thermodynamically restricted, thermodynamic limit. How to break the thermodynamic limit? You have to do additional engineering. Then chemical engineer come into the picture. Okay, chemistry is not sufficient in that case. Now, I will talk a little bit about the same chemistry. You can see that it is a non-polar molecule. You might have heard about sp hybridization. S orbital and p orbital hybridized together, and carbon is in sp hybridization, and oxygen is in sp2 hybridization. Okay, because of that one, there is a partial positive charge on carbon, partial negative charge on oxygen. Okay, and then what happened actually, the trick, as a scientist, the trick is actually, I want to get the CO2 molecule in my material, catalyst. Okay, so you have to have a metal that can give electron either to carbon, or you can accept the electron from oxygen. So it will be a metal, what you call electron donor metal or electron acceptor, and that will actually come and then slowly sit on the material. We have to have this material, I mean what you call CO2, at the surface of a catalyst chain. That's the first step we have to do. For that one, you have to design the catalyst with the knowledge of the chemistry that you have in your hand. Okay, so you can see that you might have heard about Lewis base, pi complex, Lewis acid, and different terms and how to define the material. Have you heard about molecular orbital energy level? Molecular energy level? CO2, this is a +2 standard, I guess. +2 or BSc, something like that. Okay, so we have a carbon orbital and oxygen orbital, and make it in, and then energy level split in such a way. And you can see that 16 valence electrons and the 4 sigma HOMO, and then 8 electrons 2 pi. Okay, don't worry about it, I will explain in detail. So you have certain electrons in the sigma and certain in a pi. I'm trying to bend this guy. It is actually linear. I try to bend it. How to bend it? And that pi electrons we have to tune with respect to the catalyst we are doing. Okay. So now, when I take this one, so if, for example, CO, it's a straight line, the bond angle is 180 degree. Okay. The moment it's actually coming here, it will reduce 190 degree to less than 180 degree. If it is going this way, it is more than that one. So it depends on the catalyst. I mean, say for example, carbon is coming only about something, this will go this way. If both oxygen is coming, it will come this way. So whether your metal is electron donor or electron acceptor, depends on that one. CO2 molecules sit on the surface of a catalyst, and that will push the CO2 molecule to change the linearity to some bend structure. Then the system will activate. And when it is actually bent, what happened? You can imagine when it bend any system, to take a stick and try to bend, what happened? And it's actually try to elongate. The bond, the C2O bond, try to elongate, because the electron is transferring from either from metal to carbon or oxygen to metal, the bond elongates, and bond become weak in nature. Okay, so bond become weak in nature. When bond become weak in nature, the system actually, the CO bond will break. That's a trick. That's a basic trick you do. So, but for doing that one, you need a massive control, atom level control of your atom. If you don't know that one, I want to have an angstrom level of control, metal 1 and metal 2, I mean that bond distance I have to control. That's a chemistry we play around. You can see that here, the energy, 225 angle, whatever I was talking about, or the angle here, 135. The total energy, you can see that one, this E, when it is a 180, the energy is high. The moment actually bringing, actually it is bringing down. And you can see that the bond distance also, CO bond, from 1.15, very tight bond, it's actually slightly relaxed. Okay? And then this is published in 1961, you can imagine, I mean this is proposed, I mean long back. It's not a new chemistry. Okay, so, but we are trying to utilize the knowledge that we thought about, I mean long back, how we can efficiently synthesize. Okay, I will add one more slide here. There are a lot of proposals, you can see that one. Suppose if you take a 1 metal or 2 metals, or if you take a 3 metals, if you take a 4 metals, the way you want to control the CO2 molecule according to your wish, you can do it. Keep in mind, it is extremely hard to control atom level. These are all theoretical proposals, okay? When experimentally, we do see that when we have certain in situ, kinematical experiments. While doing this experiments, how the atoms are moving, how the bonds are changing, how the CO2 molecule is actually strongly or weakly, and when you convert on CO2 to methanol or methane, how that intermediates are forming. And short-lived intermediates, we can trap it. So that we do observe. Okay. So that's just basics. So these are the activities in my group doing, and we capture CO2 from air. We do that one. We have a technology that we use from peanut shell. You might be knowing peanut shell. I may show one slide. Peanut shell, India is the second in the world in the peanut shell production. Okay. And what we do peanut shell? Just eat it and throw it. That's all we do, right? So it is a waste. It's a biome waste, and it will go to the the decompose, and then it is okay. But we have taken that peanut shell, process it, and made a material and capturing CO2 from air. And further modification also we do that one. We have a patent also, and we are testing actually in a Bangalore city, different location, how this peanut shell can be used, efficiently used, for the capturing of CO2. And if we go further, we have a lot of other technology also. And whatever CO2, captured CO2, converting by photo using solar sunlight, thermo by using electricity, and electro again using electricity at a different potential, and converting to your chemicals and fuels. So if I show some examples here, methanol, CO, methane, DME. You all may wonder, CO is a poisonous gas. Yes, it is poisonous. But here there are importance. This is a $1 trillion market. CO is actually any compound, any material can be produced from CO. Okay, it is an important chemical. Syngas, CO and hydrogen together called syngas. It is the most important material, compound actually, that industry using for the production of anything you can think about it. Or synthetic fuel, CO plus CO2 plus hydrogen together called synthetic fuel with a particular composition. And then what we'll do actually, this methanol can be used in fuel cell as a fuel for the production of energy, or this hydrogen can be produced. We have a hydrogen generation unit with a bigger capacity also, and from the hydrogen we can use this hydrogen for the reduction of CO2, or this hydrogen can be used in the fuel cell for the production of electricity. Keep in mind, if you are using hydrogen in fuel cell, only water is the byproduct. But if you are using methanol in fuel cell, we have carbon dioxide also. Some philosophical question can come in, so why you are using methanol? Yes, the point is actually, again, we can capture CO2 back and then cycle it. So that is a kind of a sustainable cycle actually we are doing in our laboratory. In all this process, what we do, we develop the catalyst to reduce the energy requirement. That energy level we reduce and then improve the performance. Okay, so we have to do, when you do the technology transfer, you have to compare the price. Okay, what is the price comparable to the existing, say for example methane, CO2 to methane is not going to change the methane whatever in the market. It's difficult because that much cheaper method we can produce. Okay, but methanol, yes, we can do that one. Or if you can think about methanol, propanol, ethylene glycol, everything, and this is a recent article. They calculated the energy and every other input, and they calculated the cost of per ton by current market price and then produced from CO2 as per this one, and you can see that produced from CO2, all of them are below X system, and you can see that methane is kind of the proposed as, but still is a debate going on. Now what we do actually, chemistry, we just make the compounds, difference methodology. Okay, don't worry about this one. For example, if you look at them in structuring nanoparticle, it can be rod shaped nanoparticle, it can be plate shape, it is a quantum dots, it is a porous nanoparticle, and you can also use the support. I mean, if you have a catalyst, say for example, Haber process, you know that one, right? Ammonia synthesis, what catalyst used? Iron, right? And this iron catalyst, I mean, used in that one. Iron, if you can uniformly distribute at a particular support, the activity can be improved further because the active surface available for that particular reaction will be enhanced about that one. The same principle we use here. So whether it's a carbon nanotube, graphene sheet, or two-dimensional structure, in whether we can distribute them uniformly, or you can control the shape also. There are rules actually called the polling rules, whether the activity at the surface or at the edge, at the corner. According to the chemistry, corner is more active in nature, and then followed by edge, and then surface. So as a chemist, I try to make as much as possible corner and edge to make it more active. Okay, it's called Polling's rule. If somebody, I mean, it's a BSc again, Polling's rule. I don't know whether you are learning that one. And there are 5 fundamental Polling's rules. You can learn it, and then this is edge or corner or face, I mean, whether it's active or not. Okay, so these are the method. I mean, I'm not going to the detail, but we use lot of different. Let me see. Yeah. Okay, so conversion is not easy. I told that one. Say for example, you know urea. Urea can make it from CO2. Okay, so here you go. Say for example, ammonia, you take them in with the CO2, can make it. And you see the market 160 megaton per year production capacity. Okay, so urea can make. Or if you want to make them in a carbonate, polycarbonate, you can see that one. Or you just make them in a cyclic carbonate. You might be using the DMF in your laboratory, probably. That also you can make it from CO2. It's storing CO2. Okay? And if you look at, I mean, anything you can think about, methane or this kind or this one, anything, I mean, you can think about it. But I'm saying actually any chemical you're thinking about that can produce from CO2. Theory is there, but practical, economical viability is the issue. Practical is also there, but economical viability is the current issue. And you can see that if you just use hydrogen, there are 17 different products reported as a direct conversion. And then further, I mean, you can produce actually other chemicals. So if you are a smart guy, if you are good in actually producing CO2, I mean, to something like methanol, it's $1 trillion market, easily I can say. Somebody is going to succeed in production of methanol in economic way is going to be a millionaire, billionaire, if the proper patents and everything, technology, knowledge in hand. Okay, so what we achieved in our lab? So I just mark thermocatalytic, this one, electrocatalytic, this one, and photocatalytic. You can see that one, we produce ethylene, at least 3-4 papers are there, formaldehyde, ethanol, carbon monoxide, propanol, methanol, dimethyl ether, isobutylene, propane, higher hydrocarbons, methane, acetone, formic acid, acetic acid. We reach so far C12, okay. So C12, our target is actually C18, that is nothing but sustainable aviation fuel for aeroplane, jet fuel, we are thinking about. But that is extremely difficult. But this all we succeed. And then you can see that methanol and DME, we already scaled up. Even methane also, we already scaled up to the capacity, as you mentioned, 300 kilogram. Now we're building a plant of 1 ton capacity. And next time we are actually in the process of 10 ton capacity plant in a sugar industry. I will come there some example. How much time I have? 10 minutes. Okay, so at the interest of the time, I will not talk my chemistry, my publications and all. So here you can see that one. Just I want to show a couple of slides before going to the translation. So here, C1 products. I'm talking about C1 products from CO2 are CO, formic acid, formaldehyde, methanol, and methane. Okay, and if you look at the mechanism here, If you do this way, okay, say for example, if you just dissociate and you can get a formic acid, or you can just continue this one, both this one actually breaking, this bond is breaking, you can get a CO. And if you continue further hydrogenation and then just break in formaldehyde, and if you continue further and if you are breaking this bond, you will get a methane, or if you are breaking this bond, you will get a methanol. It is like taking a scissor and then cut it wherever you want. Okay, so as simple as in the paper. But the problem is actually, as I mentioned earlier, thermodynamic limit is an issue. And often you end up in multiple products. The selectivity of a particular or desired product is an extremely hard. And you get a two products. And another problem is actually purification. The purification cost will be added into that one. And when it is a purification cost incoming, and the electricity, and all this together, well, those who are going to invest the money say bye-bye. I don't want to invest the money for that one, including the government. Sorry to say that word, because it is not a profitable business. So we have to find a way to get 100% selectivity with the full conversion to a particular product. Say for example methanol, can we get it actually, or methane, 100% conversion selectivity? It is difficult. It is difficult. Okay, so I will not, I have a lot of work to show you, but I will skip it, all these things. Yeah, so now if I go to C2 product, okay, that is C1. If you go to C2 product, there are enormous number of mechanisms reported. Chemistry I'm talking about. And I take two examples. Suppose if CO2 is actually absorbing into the metal surface going this way, called ethylene path, you end up in ethylene. Suppose if this is not happening, this guy goes to this way and end up in acetic acid. Okay? Of this is not happening, it will come here and it will form glyoxal. And if it is not forming, it will go here and then glycoaldehyde. And if it is not happening, it will come ethylene glycol. If it is not happening, it's continuing acetaldehyde. If it is not happening, ethanol. So if you want to make ethanol, you have to cut down all other side routes. Okay, so everything outside is very nice, but minute information you have to gather over a period of time. We published the papers, we have a patent also in ethanol, but I am not showing some of the things. One work maybe I can show in ethanol. Just please excuse me. So when I am going to talk about chemistry in depth, here red phosphorus, you all know phosphorus. This is naturally abundant one. Phosphorus already used for CO2 reduction. But when you use CO2 just phosphorus, it will produce this one, nothing but formic acid. Now I am bringing actually our electronic energy level diagrams, actually nothing but the band gap and then valence band position and conduction band position. And if you take this one, red phosphorus, the edge position is -6 that is well suited for formic acid. When light, sunlight, we did it sunlight interact, the electron excites from here to here. And you know the fundamental problem, this is a short-lived species. The immediate electron-hole recombination. And you don't have sufficient electron at the excited state to do the reduction process, automatically the yield will be very less. So what we have done actually, we just introduced this one. Whatever the electron exciting here, instead of going here, we trap here. It is an easy process. And then you can see that banded position, this is corresponding to ethanol. Okay? You can also tune this one, banded position, that whatever in a 0.33 generate a slight oxygen deficiency. It will either go up or go down. You can tune that one. So when do that, and you get a ethanol. So you get 99% of ethanol by this method. You are using water, sunlight, and doing that way. So what my students, they have done, you forget about that side. They did over an 8 months period under sun, cloudy, morning, evening, winter, summer, different conditions. On the rooftop, they did the test, getting the sunlight, and did that one. They also did under artificial light. So then you can see that one, this is giving 84 you know, this value, and this is, I mean, I have to tell the micromole of, you know, this ethanol per hour per gram. Keep in mind, this is nothing great, okay, compared to the ethanol production in the market, but this is a starting point. Like a solar cell, it started, I mean, you know, 3, 4, 5 decades before. The efficiency we used to talk about 1%, 2%, now we are talking about 20%, 30%, right? And like that one, this is a starting point. We already pushed, I mean, you know, this whatever 55 we are getting, you know, so 35 we are getting, now it is actually 180 within 2 years. Our only, I mean, we only breaking our record, whatever the production. Okay, I'm not going, each work I can talk a bit more, but I mean, I'm not going to the detail. You also another work, ethanol, again ethylene, acetic acid, propanol, butanol, pentanol, and goes on. Okay, so we all publish these papers. It is available in the you know, the public domain. There are patents also associated with that one. And the final one, probably this is a dream project we will do in future, probably artificial photosynthesis. And then I just want to take one product, methanol. I already mentioned that one. There are certain things I want to highlight. It's a safer due to low risk of flammability. It is more stable than hydrogen. It's a sustainable and versatile energy alternative for the future. Renewable resources can be used in multiple. Methanol can be used for any other product you can think about. Used in fuel cell, and it can produce, I mean, in a blend with, I was talking about M15, M100, etc. and all. It can be blend with the petrol. And it is eco-friendly alternative. Somebody can argue that it is poisonous. Yes, I agree with that one. It is poisonous in nature. You have to take certain attention to that one. When you go to ethanol, it is actually not poisonous, and its energy density is also high. So there are a lot of, I mean, you know, calculations also done. You can see that the energy contained per volume, diesel, if you look at that 9,000 or 8,000 to 9,000 range, and methanol is somewhere in the half of that one. And if you look at hydrogen, whatever hydrogen you are talking about, the atmospheric condition, we cannot use it, unfortunately, because the you know, volume required even to store hydrogen is huge. And if your pressure is actually 200 atmosphere and 350 and 700 and then liquefying, and then even after liquefying, you can see that there is a half of that one. But the advantage of the hydrogen, definitely I can say that there is no CO2, there is no pollution. It is eco-friendly, but the production is actually gigantic problem. Now, this is not a new one. There is a science magazine published in 1973 when the oil crisis was there, and they proposed methanol economy. It can be one of the ways actually alternative fuel. 1973, now we are in 2023. So it is, you know, that old problem. Not only proposing, there is another science magazine, 1991, and you can see that in Chicago, this is a methanol tank. Okay, so this is actually methanol tank, and then, you know, just filling, and you can see that it's a cold condition. Chicago, I was in Chicago, I mean 2.5 years. The temperature, I mean, went down once, it's minus 35. And that is actually so windy city. You can feel it. Really you can feel it. And that's such a cold condition, and then, you know, you can do that one. Unfortunately, the technology could not have gone there because of the ethanol lobby, and the economical price of, you know, ethanol, I mean, e-turn is much better than methanol. So they moved. You might be knowing these two people. George, he got Nobel Prize in 1991 for his contribution in carbonate chemistry. And his student, so he's a Bangalorean, his house is actually in Atinagar. He joined as a PhD student with the George in 70s. And then, I mean, you know, they worked together and developed this catalyst, with multiple catalysts, and he's a professor there, I mean, same place actually. He used to come regularly. Yes, exactly. So I have very close connection with him. So he also gave a talk in JNCSR. So they started actually in 2007, and then it took actually, I mean, 8 years, 9 years, still it's not completely. But what I am bringing here, this is a plant here, is in Iceland. They did the plant in Iceland, nowhere else. The reason is actually, that is a geothermal electricity. Geothermal electricity, if you convert, I mean, the cash into rupees, I mean, so it is a 1 rupee per unit. Here electricity cost is 7 to 8 rupees. This technology, we cannot take it here, unfortunately. Okay, the catalyst developed by Johnson Matthey, and I know very well, I mean, you know, this what is the performance and all. And you can see that one, this is a 4,000 ton of methanol per year capacity they are producing. Okay, this is a small plant. It's nothing big. People are talking about 1 lakh, 2 lakhs, methanol production plant. Okay, so there are a couple of them are building in China by similar technology, but the coal cost, that is subsidized by the government completely. There are manpower and etc. So many parameters involved. But it involved, in this way. And we also contribute. I just want to summarize the catalyst we have developed. One term, I want to bring it to you, space-time yield. You might have heard about this many amount of CO2 converted to this many amount of methanol. Like that, any organic reactions, if you talk about yield, you calculate, right? The same way, if you calculate the space-time yield, it's nothing but gram of methanol per gram of catalyst in an hour. That's a calculation. So if you look at this value, 0.3 and up to 4.3, and you can see that the blue and green, that's a contribution from our side. And this one, we are talking about the competition, we scaled up this catalyst. That's a 0.6. That scaled up to a synthesis 10 kilogram in a batch condition. We synthesize in our lab actually. We are also in collaborating with the big industries to scale up. So, I'll take 5 minutes. Okay, just wind up quickly. So here, we have the startup company. As I mentioned, actually we have a lot of recognition received. Particularly thanks to Karnataka state government. We received the first award from Karnataka state government in 2017. And we got enormous funding from various sections. And then we demonstrated the 300 kilogram capacity plant. We have an ISO certificate from a US firm, 350 solution. You can download, if you just Google it, you can download. Complete technology is available. Life cycle analysis, that is nothing but the input and output and how that is sustainable. That is also done by University of Calgary. That is also available in the public. And we got a national technology, etc., and all. And we also chartered by Stellaris, only 2 companies from India, ourselves and Carbon Clean Solution. They build a 5-ton capacity CO2 capture plant in Tata Steel. And we are working now. We just got a project 2 days before from Tata Steel to work on CO2 to gasoline. So we are working on that one. This is a technology we develop in JNCSR. Okay, so this is a carbon capture. This is a carbon CO2 conversion. This is a fuel cell. This is an engineering package. I have 2 masters actually. One is chemistry and one is engineering. So I used that engineering masters after a long time here. And then we have a methanol distillation and we have a hydrogen production unit as well. And then finally we integrate all together and demonstrated to the various agencies, BPCL, Shell, etc. and all. We demonstrated Coal India. And this is a plant in JNCSR. Okay, so we have a second campus in Hegde Nagar, 5 kilometers from JNCSR. This is the first building. I took a little bit pain. There was nothing actually there. Even there was no road, no electricity, no water. It took some time actually, and then constructed, and then you can see that the building here, and this over a period, it's a catalyst development, reactor, process, methanol distillation. Finally, my student is collecting methanol from, CO2. He's also Bangalorean basically. Okay, so we also calculate the cost of methanol. You can see that 24 rupees. Depends on the input. It can vary here and there. If your electricity cost is 2 rupees, it will reduce. If something else is costly, it can be more also. And finally, we are building a plant here in Telangana, the same technology, 1-ton capacity. And this is a 650 megawatt power plant from coal. This is the CO2, flue stream is coming. We capture it around 3 kilometer distance, and then we are constructing the plant. Today, 6:30 my flight going to Bhumi Puja for the plant construction. So it will be ready by, So it will be ready by mostly by 2024. And finally, we have a Center of Excellence, first in the country, on carbon capture and utilization. Is establishing JNCSR, funded by DST for a period of 5 years. We have our own industry sectors, academic people, chemistry, engineering, beyond that one. And some of the students may be interested. If you have a good potential, happy to come. And then there are, I'm just skipping all this part. This is also, I will just skip it at the rest of the time. So finally, I would like to acknowledge my team members, and I'm very lucky to have very excellent bunch of students, highly intellectual students. I mean, most of the catalysts, and we would say all of the catalysts developed by their immense knowledge and then hard work. And a lot of funding from various agencies. I'm also lucky to have, I mean, various collaborations, India, outside, etc. And you can see this tree, and we started from here, okay, with the seed. We are growing actually the tree with the different products. You can see the different publications, and all this you can get it from the website. So we've gone further. We also went down actually, root. That's nothing but CO2 to carbon. This is a carbon nanotube. Okay, so the chemistry still we don't understand, and I'm not explaining that one. So, but I mean, we went down also, but that is actually not energetically feasible process, but we got that one. With this, I would like to say one word actually. This is old quotation, I mean, from our Bapuji. If you want to change the world, you have to start from here. Okay, so most of the time, I confess myself also, most of the time we don't understand actually the problem outside. Okay, so this problem is a gigantic problem. Whatever the capacity, if you can contribute, I can tell you next 30, 40, 50 years, the globe is ruled by this problem, number one, along with the healthcare or quantum technology. These are the massive problem: energy, environment, technology, and healthcare. And these are the points I'm going to rule. Be smart and select, I mean, choose the best one that you can contribute. Thank you very much. I'm happy to answer any question if you have.
Wonderful lecture. Actually, at the end, I thought of asking one question, sir. After working in the research laboratory, scaling up the things, for the audience, what you are going to tell, without asking me to start with you.
Fearless, that's all.
Thank you, sir. Yeah. Open for discussion.
Yeah, so but don't take a blind risk. Calculate risk with certain, fearless nature. People or system, I would say people, system may not support you most of the time. System may not. It is not because of, system doesn't want to support you. The system built in such a way, system is not capable of not supporting you. Don't worry about that one. When you reach this level, you are not going down. So only attempt to go up. To try yourself, go up. I had a lot of problems. To be honest, it was not a catwalk. I'm still having the problem. I don't know when and where and how I will succeed, but my science, I will not lose. That much I am confident. Nobody can touch that one. I have my science.
Thank you, sir. Quickly, if you have one or two questions from the audience.
Yeah.
Sir, thank you. It was a wonderful session. Sir, my question to you is, if we use methanol or ethanol in the place of fossil fuel, after the combustion, what is the output? Is it the same CO2?
Yeah.
Then again, we are sequestering CO2 and we are again releasing the CO2.
Yeah, so that's what the comparison I made. If you are using methanol, the amount of CO2 is much lesser than compared to the existing fuel. Still, we are not going to solve the problem completely.
Sir, can we claim this as a zero carbon emission?
No, so that's what I mean. If you can sustainably recycle that CO2, utilize it again, well, this is a carbon neutral technology.
Sir, as we have studied that rather than terrestrial, ocean is a major CO2 sequester.
Absolutely.
Can we increase the capacity of ocean sequestration
Difficult.
rather than
Difficult. The
terrestrial?
amount of CO2, I mean, we are producing much higher than to accommodate these.
Yes.
It is difficult.
Usually we tend to increase the forest or sequester things, but is it possible, any way possible to increase the capacity of the oceans or the water bodies?
See, the problem is actually the amount of CO2 producing is much, much higher than the capacity we can accommodate even with the seashore. I can tell you, marine life is dangerous. How long, we can actually handle that one? Our ecosystem will be collapsed completely. It will be, yes, exactly. It will be very fragile. And dangerous.
Sir, to take an extra minute, sir, you said about the peanut shell. Peanut shell can sequester CO2. We also have straws, various other.
We can do, yes. I told one example, peanut, but we can do other biomass also. We can use. So you just modify with the chemical treatment. If you know the chemistry, you can modify and do that one. The particular one, peanut shell, even peanut shell I'm talking about. The peanut shell in Bangalore, peanut shell in Delhi, peanut shell in Goa, they are different. The metal content is also very crucial in actually, which peanut shell processed chemical is actually good for CO2 capture.
It's not like every crop recipe can be used.
We can use it, but we should know, the knowledge should bring actually by doing the science. So that variations can be there, and this is one of the reasons certain geographical location, the sustainability is well balanced. Certain geographical locations, you won't see the same tree, one geographical location, but it's a different tree. And nature is so smart actually to handle this system. If human is also understanding that one, well, you can do it. But knowledge is the power. You can do that.
Thank you, sir. Studies are available to the wrong side. You can have a discussions.
Thank you.
I have a small question, sir. Sorry, I think maybe this is not too serious and silly maybe. So you can actually, while for the vehicle, you can filter the carbon filters that can suck instead of emitting to the atmosphere. That can really, so you can reduce the carbon dioxide emission. Whether is it? Yeah.
I thought this 6 months back, and I already communicated, just to the government, say, for example, through that something. So if you can identify the location wherever you see that CO2 sector, I can do a statistical survey and try to do something on that. It is possible. Exactly. It's small quantity trial, and if you can just scale it up into the larger quantity, yes, nice. This is possible. I just want to say this part actually. This is connected, CO2 is connected with the many things. Say for example, our submarine. When there are conditions, situation, war comes, submarine goes under the water maybe 2 months, 3 months, 4 months, right? And then it is actually, 2, 3, 4, 5, 6 compartments. And just imagine people are living there, batteries there, and then so many things are there. And then it is also accumulating CO2 producing inside that one. How to do that one? Just capture and then releasing through water, right? And how the that is okay, this is fine. The problem is actually, if the enemy is there, they can identify with the spectroscopy. CO2 is there, and the submarine is in that location. They can attack. But this is what I'm talking about another problem, which is they will not survive because it can be easily identified. So the question is that capture and then convert internally and utilize instead of
Yeah, inbuilt. There is some kind of filter that. So please contact sir, and you can make really a wonderful society. Thank you very much, sir. Yeah. Thank you.
Somebody, potential students, I am a little bit tough guy. Come and then easily go there. But those who are working, you will get a good experience.
career also. I have a streak record. Anybody coming with me, they will get it.
Thank you so much, sir. Thank you very much, sir. Now I request Dr. Ganesh Raj, sir, please come and present a plant and certificate appreciation to our today's speaker, Sebastian Peter, sir. I also request to Ganesh sir, please present a plant and certificate to Dr. Ramakrishna Reddy sir, today's session chair. And also to Professor Jayashree Madam, today's co-chair of this session. Thank you, sir. And we have 30 minutes lunch break. Please assemble back at 2:15. We'll start the panel discussion. Thank you, sir. Yes.
ಸೇಮ್ ಇದೆನಾ ಇಲ್ಲಾಂದ್ರೆ ಸರ್ ಸೇಮ್ ಇದೆನಾ ಇದೇ ಥರ ಇಲ್ಲ ಇನ್ನು ಮುಗಿತಾ ಸೆಷನ್ ಇನ್ನು ಯಾರಿಲ್ಲ ಮಾಮೂಲಿ ಕೂತ್ಕೋದ್ರ
Day of afternoon session. After elaborative deliberations on this climate resilience and sustainable development for 2.5 days, now we have come to a last but one session of this conference for panel discussion. I request all the delegates to occupy their respective chairs on the dais. Dr. C. Vasudevappa sir as a chairman, Professor Katre Shakuntala Madam, Dr. Ganesh Raj Sir, Professor Ashok D. Anjigi, I request Bangalore University people to not to bias, not to do this biased, because all dignitaries are all equal, okay? And Shri K.V. Prakash sir, and Dr. Prabhakar Sangurmat sir, please. Sir. So at the outset, I am welcoming you all participants first to this panel discussion program. First, I would like to introduce Dr. C. Vasudevappa sir. He is a guru of our many fisheries graduates, including me, and he has started his career in University of Agricultural Sciences, GKVK, and immediately after his professor post, he occupied National Fisheries Development Board in Hyderabad as a Chief Executive Officer, and then he has served as a VC for NIFTEM University and also UAHS Horticulture University in Shivamogga. So I heartily, on behalf of KSTA and all you participants, I welcome you, sir, for this panel discussion program. Srinivas, floor book. Professor Katre Shakuntala Madam, she is a former Dean and Head Department of Zoology, Bangalore University, and she was a former member of KST also. I welcome you, Madam, for this panel discussion. Next, Dr. Ganesh Raj Sir, former General Manager, RRSC, ISRO Bangalore, and Sir has got more than 35 years of expertise in ISRO as a scientist. I welcome you, Sir. Next, Professor Ashok D. Hanjigi, Dean Faculty of Science, Bangalore University, and he is having a very good expertise in geoinformatics. I welcome you, sir. And next, Dr. K.V. Prakash, sir. I will give one example, sir, 1 minute. You are telling about mitigation and all. Actually, yes, sir has studied, he is our super senior, he has studied mitigation and all. Actually, yes, sir has studied, he is our super senior, he has studied fisheries. But now, he has established more than 8 companies and not in fisheries, and they related to this climate resilient like water recycling and high-end laundry service, and he is worth more than many 100 crores. So I welcome you, sir, for this. He looks to be a very simple person, but he has given many job opportunities and he is helping others also. Next, Dr. Prabhakar Sangurmat sir, former Executive Director, Hatti Gold Mines, and presently serving as a board member for Hatti Gold Mines. I heartily welcome you all for this panel session. Next, over to Dr. C. Vasudevappa sir, Chairman, panel session. Sir, please. Sir, mic you.
Good afternoon, everybody. Good. I hope you are, I would say, alive after a good food. So, I think, we will make it interesting for all of you. And probably this is a session where we are making it more interactive. We don't wish to speak much, but at the same time, the subject will be introduced to you by each one of the panelists, and then probably we will invite questions. And if you have heard all the topics for the last 2-3 days properly, probably I think you will have many more question marks. So that can be got clarified, but at the same time, I wish each one of you be very attentive and ask pertinent questions. This is something which always, don't drag it to something which is maybe of personal benefit or use, But all the same, that is also taken care. But I wish you people will really take care of all that. And I should, in the beginning itself, I should say my great thanks to this organization, KSTA, Dr. Ramesh, and others who are there in this institute, and to be especially amongst all of you today afternoon. So thank you very much. Now I think, just coming to the panel, probably I don't have to even just introduce Professor Kstacademy Madam. She was my PhD examiner. I don't forget that. And we traveled together from Bangalore to Cochin and came back in the same bus. So that's how I think, and it was really great, and she has been always a source of inspiration and motivation as well for all of us, including my junior in the college, but of course, who has grown to a very big height like Dr. Ayyappan. So he was guided by Dr. Kstacademy. That I think will speak of her capacities and her involvement and her scientific temper and a sort of a motivation, making people understand and taking the department to the newer heights and all that. So she will be there with us, and absolutely it's a delight to listen to her. And then of course we have Dr. Ganesh Raj from ISRO. ISRO, you know, after the Mangalayana, ISRO has gone to the sky itself. Probably I think that is something which always we cherish. We always really enjoy, and we are very proud of. And he is from such an organization. I wish there will be many more things which comes to you, especially from the space perspective or the years perspective or environment perspective. So thank you, sir. Thank you for your kind presence here. Of course, Professor Ashok, I discussed quite a lot. Dean, Faculty of Science, Bangalore University. In fact, even pre-university earlier was under the universities. And I am a product of Bangalore University for my PUC, pre-university program. Way back in 1968-69, that was a great moment for us. And of course, it has grown leaps and bounds, probably diversifying in its own areas and all that. But at the same time, I know it has got a good accreditation like A++ or something like that. And that's a great achievement for the university. I know this is our institution which we need to nurture, nourish, and probably take it up. So thank you, Professor Ashok. And Sri K.V. Prakash ji, I think he is my junior, of course super junior I would say that. But he is one who has taught the graduates coming out of the university how to become an entrepreneur by himself. And always we speak, you should become a job provider than a job seeker. So that I think he has 100% done it. 7-8 companies under his belt, and probably trying to address different kinds of issues. It is just not fisheries alone. Maybe part of it is fisheries as well, but all the same, looking into the climate resilience, looking the agricultural production, maybe the industrial sort of environment, all that I think he has brought in, and I am very proud that he is there with us. Dr. Prabhakar, I think, Sangur Mutt, he has been a man himself, he is a gold man. Because he works for the Hatti Gold Mines, he is the director there now, and he has retired but continued by the government. I nominated him because of his, I would say, hard work and dedication, and that is one thing which he always cherishes. That's what he was telling. Mining has to be part of all these sciences which are supposed to be covered under the climate resilience. And unfortunately, it is forgotten. There is nobody, not even one person who is into mining and all that. So the Mines and Geology Department. So that's where I think, it's a science. I told him one thing. It's a science we need to understand. It is a science which has to get into our minds as well. It is today's world. It is not a particular branch of science in which we are trying to get specialized, unless otherwise you are really motivated to become a scientist by yourself and also to specialize in that particular area. Otherwise, a normal human being or a student tries to understand the try to get the core competence in the area in which he wants to specialize, or he wants to establish his own facility and things like that. That means it is more a self-dependence. That's what he has done, and he has been doing, I told him. So this is a great moment for all of us to listen to him. I can thank you very much, Dr. Prabhakar Sahab, for your kind presence here. So let me speak few things on climate resilience. Because as chairman, maybe I'll just introduce some of the things which are very, very important for today. And I would say here, I don't know the time limits they are not given. What is the time that is given for this whole panel? Come on. Yeah. Maybe I think we will just restrict to say about 10 minutes. Is it okay? Or you want more time?
5 minutes for us and 10 minutes for you as a chairman.
Okay. So I think that's where I think we need to really be, we'll try to really make it, try to make it more interesting as well. I know we have been talking about climate resilience. This is not a new thing for us. The ecological resilience is there for hundreds and thousands of years. And the ecology by itself, by nature by itself, used to rectify the mistakes in the environment and try to support the life which is existing on the globe. So that's what used to be. Now what has happened with the human intervention and probably the industrialization, urbanization, and I would say even the population growth. These things have created more and more opportunity to harvest rather than harnessing the resources that are available on the globe. That is the reason we need to be going in for climate resilience. So climate resilience is nothing but trying to combat the problems and issues which are created by ourselves and try to establish a stable or a sustainable globe which can support a good quality life for all of us. That is what I would say that. And of course, the Paris Agreement on climate change has really made it very clear. All nations have agreed that by 2050 or 2100, that's what. So the temperature of the globe or the climate will not rise more than 2 degrees in any part of the whole world. So that is one thing we need to, because already we have the temperature, global warming has taken place, 0.2 degree has gone up now. That means it takes maybe decades of years to increase even by 0.1 degree. So that's where we need to be very cautious and we have to take care of this. This is our responsibility, I would say maybe, I think that is very, very important. So the cities, in fact, I would say, we have gone for urbanization. Most of the population, I would say, by 2050, 65% of the population will be in cities. Imagine what would be the impact on the environment and the water resources and probably the waste that is generated by each one of us and how do we dispose of this and the industrialization on the other side. And our rivers have gone now. In fact, I would say here, the rivers, especially the riverine systems which were existing and supporting the life, and the entire civilization was on the river banks, I would say that. Now, civilization has become an individualistic approach, and rivers are not there, natural resources are depleting, and probably that's where I think we need to really give a focus on how we can really manage ourselves with the limited resources. Or how do we reduce our dependence or over-dependence or over-usage of some of the natural resources that is available, especially I would say with water, and also with the waste that we generate. How do we change it? See, that's what we have been talking, Modi ji has been talking about circular economy. What is that circular economy, first of all? It is, nothing is a waste in a system. In a production system, nothing is a waste. That means, including the residues, need to be converted and into a usable product or a useful product, and that means there is nothing which is lost or which is waste in the whole system. So that circular economy has to come in for us, and only then probably we will be able to address some of the issues. Probably you know Bangalore, once it floods, heavy rains are there, people get struck everywhere, and very unfortunate to see some people dying. Going in a car and getting, probably I think immersed in water, and that is something which is very, very bad. That means it is the cities which create more problems than the rural areas. And plus, of course, the vehicle movement, the carbon dioxide release. I think it was nice that the previous talk was on how to harness carbon dioxide, convert it into a useful fuel. So these are all something which are very, very important for, I would say, the climate resilience. Of course, there are a lot of things, especially from the perspective of public health. We need to really take care. If we have a healthy environment, probably the people will be healthy, their output will be better. That means the country also will grow in terms of GDP. Otherwise, what is happening today? If you look at the whole globe or the whole universe, India is the country which spends a huge money on the medical treatments. In fact, compared to even Westerns, our expenditure is much higher than them. So why? Because we are not able to maintain our health because of lack of good environment and probably lack of good water per se, and also lack of good quality food which is hygienic. So these are all things which we need to really understand, and probably I think these are things which are very, very important. We need to really take care of that. So let me come to the last part of it. That is one thing which is very important is there are 5 pillars of climate resilience. They are like, one is the threshold capacity. That means up to what level we can interfere with the environment. That we need to understand and try to reduce your activities or balance your activities in such a way that you do not cross the threshold levels. That is very, very important. So that's what I have been talking. So probably all that need to be really addressed. Second is, of course, is the coping capacity. How do we cope up? Maybe I think it is the people, the community or the society which is within that area, or maybe the neighboring states or neighboring countries. We need to come together probably to address some of these issues. Then only it is possible for us to really, of course, the technology is one where the technologies are coming from different parts of the country and also from the outside world, and that we try to adopt. I would say one example, especially converting the waste into a useful product or into fuel and things like that, this technology is becoming popular. So that's where I think we need to really understand that. And then, of course, the recovery capacity. How do we recover from shocks? Such of these shocks, probably that is one thing which we need to really understand. And that apart, I think the adaptive capacity, this is one thing which we need to really learn. Because through learning, probably the adaptation mechanism, so has to be really well understood and brought into the place where we can really adjust and accommodate whatever changes are there, and we try to understand that. Then, of course, the transformative capacity is, this is an infrastructure which you want to create for future, anticipating or projecting what would happen by 2050 or 2100, probably then we need to develop our technology. This is what is the transformative thing. And I would say here, the ecosystem services, we need to really understand well. Could be water, could be terrestrial, could be air. I think the ecosystem services which we derive, if you have not understood properly, don't think it is for free. For future generation, it will not be there. That means we have to pay a very heavy price for such of those things. I know the sustainable development is another part, where the sustainable development goals, there are 17 sustainable development goals which UN has declared. Out of it, the goal 13, which speaks about the climate action. So this is something which is very, very important for us. We need to really understand that, but this is linked with many other sustainable development, maybe another 6 or 7 of them. So this proper understanding of interlinkages and interdependence and collaboration and cooperation, I think these things become very, very important as we go further. So I wish this I thought I should just bring it to your notice. But anyway, I had a lot of points, but anyway, my time is already up. So thank you very much, and I wish all the best for each one of you. If you have anything, you can always say. Now I request Madam and our Guruji, oldest, yes. Okay, that's fine. No, the list you were second. That's why I thought I will call you. Okay. We'll go to Dr. Ganesh Raji. Then I think he will take it. Please. Hello.
ನಮಸ್ಕಾರ ಎಲ್ಲರಿಗೂ. ಅವರು ಸಾಹೇಬರು ಚೆನ್ನಾಗಿ ಹೇಳಿದ್ದಾರೆ ವಿಷಯ ಎಲ್ಲ, ನನಗೆ ಜಾಸ್ತಿ ಆ್ಯಡ್ ಮಾಡೋಕ್ಕೆ ತಿಳಿಲಿಲ್ಲ. ಬಟ್ I would like to give you different dimensions. ಯಾಕಂದರೆ first my advice, don't get worried. Nothing will happen to you like that, except some flood or something happening. Danger like possible extinction may happen after hundreds of years. Because, as I told yesterday also, our age Earth we have not understood. 71% water. Under that, we don't know what is exactly. Why only Earth is life? Why not Mars? Why not Venus? Why not Jupiter? Why other galaxies? We don't know. We are, it's like, I remember that, no? Gottala. Our understanding is limited. I'm very frankly telling you. What we know is less. Carbon dioxide, methane, nitrous oxide, everything increasing. But 70% is nitrogen. So we need to have a different dimension. We will think, no doubt, but I feel natural disasters kill more people. Earthquake in Antarctica killed 50,000 people in one stroke. 10 million people got lost their house. Landslides, volcanic eruption. Natural disasters are also very dangerous. And climate change is not only due to human intervention. We don't know how it happens. Then we know La Nina, temperature increase in Pacific Ocean. I don't think anybody puts fire in the Pacific Ocean. It happens. We don't know exactly. We are not understood. You will agree with me. We don't know interior Earth itself first. Plate tectonics, 150 kilometers thick, moving, colliding Indian plate, the Chinese plate, earthquakes. See, it is a lot of confusion prevails according to me. So what the statistics youngsters think? Do more research. Find out. Disprove all of us. But take good action. You don't contribute. Adopt a lifestyle which doesn't contribute to further polluting at least locally. Like air pollution in Delhi. It is man-made. Water pollution in Bangalore also man-made. Such things we can reduce, no doubt in that. We need to reduce to have a healthy, safe life. But satellite data is available, no doubt, for last 40 years. We can study some extent. Recorded data is only 150 years, not more than that. No one is having it, except fossils. Whatever people speak extinction becomes fossil study. That also, oldest fossil is 600 million years old. Below that is, we know our Vasta coast was 800 million years old. That is already changed, it became a rock. There is no more a fossil. So we need to find out our indicators, fossils, rocks from different planets or different things. What is the age? What happened? Whether there is a sun flare, Earth may get burned in no time. Our Aditya alone is going to do that only. Setting from day. Imagine sun shrinks. It's a plasma state. What happened? Earth will become ice. Glaciation. So a lot of uncertainties. So all students or others have a wonderful opportunity to learn. Think in different dimensions or out of the box thinking. So you can contribute in various fields because I am telling you what is found out is very, very, very less. With all people, with due respect to them, get to understand real problem. So these are my words. Thank you.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. I am Dr. Sangur Math, basically a geologist. I was very eager to see is there any geologist or a mining engineer or a metallurgist to search in here. You said it's quite interesting, you know. Just I'll take you for a while to the interesting things. Next to agriculture, the mining is the more economic activity. I think everyone will agree. India ranked third in the world in terms of coal, lignite, steel, zinc, and bauxite, etc. Indian mining industry makes a major contribution in the national economy as well as to the well-being of the society as a whole. Mines are the source of wealth. From the wealth comes the power of the state. Indian mining is more than 2000 years old. The first mining record of accounting of the mining started systematically in 1774 by the Britishers. 1774 by the Britishers. When we talk of the climate, environment in relation to the mining, economic contribution I told, equally I am now coming to the climate and environmental mining. Okay? We have to consider the mainly three attributes. One, physical attributes due to mining is a land, air and noise. Next, biological is flora and fauna. Next is a human, because to start a mining, we have to displace villages and people will migrate from one place to other. Currently, there are about 611 coal mines in our country, 150 oil and gas projects. About other than this, all granite, everything else includes about 13,932 mines in the country. But for the whole country, only one gold mine, that is Hatti gold mine. Now, the total working force of the mining industry in India consists about more than 1.5 million workforce now, total. So, by this one, now we are mining in a country about 95 minerals, 4 fuel, 3 atomic, 10 metallic, 23 non-metallics and 55 minor minerals. Okay? With this thing, now I am coming to the effects of the mining on the ecosystem and groundwater, etc. Mainly we have got two types of mining. One is a open pit mining, another is a underground mining. Maximum is a open pit mining only. Except Kolar and Hatti in Karnataka, no other underground mines are there in Karnataka Special Authority. Now, impact due to open cast mining is deforestation, which drastically changes the climatic condition, geomorphological changes, which include the change in the topography of the area, slope pattern, overburden and dumping of the mine waste over a large areas, making them unsafe, diversion of nalas, rivers, and this will change the drainage pattern, toxic pollutions, sometimes toxic substances over the overburden in the mine water and tailings dissolve in the air as well as in the water and etc. Discharge of the acid mine water in the streams, degradation of the agricultural land, spontaneous combustion of the cases of the coal, change in the rainfall, atmospheric humidity, noise due to blasting and due to blasting operations of heavy machineries, industries, ground vibrations. These are all due to the open cast mining. And coming to the underground mining, main is surface subsidence. You might be seeing is that one, now we have seen that one people have struck up in the tunnels. You imagine how we might be taking the underground mines up to the 3.2 kilometers, now Hatti is a 1.5 kilometer. How much risk is involved in these things? And the mine fires and air pollutions and removal of the vegetation of the topsoils, etc. So these are all the major impacts of the mining of this one. Now there are about 280 accidents in the mines due to the roofs and site collapse, machinery handling, explosives, cyanide, and heavy truck movements, etc. 280. Contributing to the mining economy is contributing to the 10 to 11% to the economy and 1.6% to the GDP. Mineral productions of the 2023 was 2,28,000 crores. Indian economy is facing unprecedented effects of climate change and frequent occurrences of natural disasters, which nearly 3% of the GDP. How much we are contributing to the GDP and how much we are bringing to the law, this side. Karnataka state has planned to increase the GDP of the state to the 1 trillion. Increase in growth rate in this one will be for 1 trillion. Agriculture from 13.3% to the 16.3%, agriculture sector. Industry 8.8 to 16.8%. Service sector from 14.7 to 16.9%. And mining sector from 0.9 to 12%. So overall aiming rate is a 16.8 by 2032. Because I am involved as one of the mining committee chairman in the 1 trillion budget. Just I am providing all these statistics too. And royalty collected by the government of Karnataka in 2023 is a 6,300 crores. And one more interesting thing, madam. Female participation in mining is hardly 4%. Now, with all those things, now comes what to do for all these things and effects and all that. I told one time what is the income, what is the job opportunities, and what are the things is involved in this one, what to do and all those things. For this thing is environmental management plan. No doubt we required a mineral. Equally we have to protect the environment. Same thing. It has to be put. For this thing, we have got in every industry and everything else. There are a statutory department like a Director General Mine Safety, Pollution Control Board, and Department of Mines and Geology, everything else. Now everyone is monitoring and controlling it. Main thing, preparation, demarcation of the mining affected areas by utilizing the state-of-the-art smart technologies like drones, etc. Demarcation of the drainage basins, etc. And in geomorphological studies, slope stability studies, and other environmental parameters of fauna, flora, etc. But however, interesting thing comes is that one. Suppose I will just put in one example. What is our demand and supply? Just one mineral I'll take. Now in India, we required a demand for the gold is at 1200 tons per year. 1200 tons is a gold demand per year, only one metal just I am putting. And our production is only at 2 tons. And we are importing about 930 tons. One now very interesting thing I will tell to all the ladies. How much Indian ladies are having the gold in their house and in their banks? No, it is there. We have got India Gold Policy Center. We have done the research. We have done a survey. Yeah, good. Yes, sir. So, Indian household gold, what our ladies are having is about 20,000 tons. 20,000 tons of the gold is available. This we have done for this thing, and there is a special research center in Indian Institute of Management, Ahmedabad. For that thing only, India Gold Policy Center is there, sir. Now, by doing that one, mining and all those things, no doubt mining is a must, we require. But we have to go ahead for how to utilize it, reuse it, that one, mine waste and all those things. Now technology has changed, metallurgy has changed, exploration methods have changed. Now, earlier we used to analyze only for the 1 or 2 metals like a gold, copper, coal, iron and all. Now we have to analyze for the entire periodic table. We have to recover all the metals available. Now I'll tell you, we had one copper deposit, that's called a Tintani copper deposit in Gulbarga district. It was an earlier copper deposit. Subsequently, by economic feasibility studies, it has become a gold mine. Now it has become an uranium mine. Because of the analytical chemistry has advanced, technology has advanced, our mining method has changed, and we are going for the safe, sustainable, eco-friendly mining. Now coming to the interesting point, how to utilize waste to wealth. Everything has to be reused, that one. For that thing now let us take a gold ore tailings of the Kolar gold mine. Everyone we are talking, we are almost more happy after seeing the KGF film. History repeats. What I want to say here, Kolar gold ore tailings is there now, big heap. Earlier metallurgy was not advanced, another time a lot of the minerals we could not recover. This is a research topic for all the youngsters, this is what I am telling you. You have to study that one, what are the other minerals available with that tailings. Whether that one we can use as a agriculture micronutrients in that one, or any other minerals we can recover, or civil engineering people can study that one, whether we can utilize as a road metal. Central Mining Research Institute studying that one. Whether we can use it in ceramics, how we can utilize it. Now suppose if I want to shift that one from that place to other place, earlier I told you again our metallurgy was not advanced. In that one arsenic is there, cyanide is there, tomorrow our news friends will come there. You know all those things. Now this is the research area what we have to do. Now coming to that one, Kolar gold mine, again I am telling you, mine has gone about a 3.2 kilometer depth. It is now completely water filled. That water is about a 30 million cubic meters. 30 million cubic meter water has been there. That is no doubt it is a polluted water. We have got advanced technology. We have to treat and reuse it where it is available. Like that throughout Karnataka, there are about 400 old gold and copper mines are available. Because they have been closed and abandoned because of it was not economical. Now they are all water filled. Those can be utilized for the after treating the water, like a zero discharge of the water using a reuse, recover and recycle. And we have to use a maximum solar energy in that area available in the Hyderabad Karnataka, and we have to carry out this very systematic afforestation, solid waste management, biomedical waste management, and biofuel species. In our all the mining areas, mining sectors, where how we have to go eco-friendly climate change, biofuel species. We have done this one jointly with the University of Agricultural Sciences, Raichur, biofuel species, this one, and awareness program, and ultimately, no doubt, we required a mineral and everything else, not at the cost of the environment or anything else, not at the cost of the climate, because our last 35 years I have worked in the mine. How was the condition I have seen here? Now, how is the condition of improvement? How are the things? Now, almost once in 2 years I visited Jammu Kashmir. Last week I was there in Jammu Kashmir. I have seen the changes, what is happening in the Jammu Kashmir. Gulmarg, earlier I used to go with the heavy sweaters and cloths and all the things. Now this time I felt I am not required there. Completely changing in the Jammu, that Himalaya, dynamic Himalayas. So our aim should be development without a destruction. I am again repeating, friends, our aim should be development without a destruction. Our aim should be very safe, sustainable, eco-friendly mining. Then only we can achieve this very peaceful atmosphere, and we can live very happily with a pure water, pure air and good health. Thank you very much, sir.
Thank you, sir. It was a very interesting and wonderful discourse. I would say that. I know it's especially for mining. We have touched upon the space and we have gone deep down into that is mining. Now let us come on to the land. Maybe I request Dr. Prakash. So K. Prakash, who is the founder director of Remote Bangalore and who has been a successful entrepreneur on the road. Let us know. It's a big class.
Thank you, sir. Let me correct, I am just Prakash K. I did my only graduation under the great University of Public Health Sciences with fisheries as my specialization. I became a specialist in breeding shrimp and fishes, and everything was related to water. So we became more specialized in breeding shrimps and had many projects all along Indian coast and even overseas projects. Somewhere I felt that I should do something for my country. That's how I moved from Chennai to Bangalore to take up with some wild dreams, many projects. In fact, the first one I took is on industrial level laundry and dyeing business, which is currently serving more than 40 leading premium hospitals and also more than 40 premium hotels, plus airlines and retail segment. This initiated a lot of things in my mind. We had a lot of challenges when it comes to recycling water. So we have to use the water and drain it. With the permission of the government, whatever you do, we realize that there is no technology to justify the need of small-scale industries who are genuinely wanting to do justice to nature. Then this sparked my mind. We have seen a lot of aquaguards and small-scale RO-related membranes filtering water for our household requirements. There were no such things for industrial level. Then this made us go for innovation. During this journey, we took 8 years to arrive at a technology which can replace the conventional one, which can mitigate all the effects and OpEx-related challenges with respect to the genuine water filtration system. For your kind information, I think more than 3,500 ETPs and STPs in Bangalore alone are dysfunctional. The threat here is that we have licenses, but we are not able to treat, and we do all the things to take the licenses, but statutory things are so stringent, but in ground reality, majority of them are not doing justice to that. This hurt me badly. We have been working on water for the last 20-25 years, but we could not find a solution. This made us to arrive at a solution called Kstacademy technology, which is not a solution not just used for our own project. We expanded that as a company by itself. So second company is born, and that became a technology by itself. Now, currently, every day, 250,000 liters in the past 10 years being recycled and reused back in the process. And next 1 year, it will become 10 lakh litre a day, means 1 million litre a day in our own project. This has made me to look at getting to business by itself. So the company is born, one company is born, and now it started selling machines to so many companies and having a lot of orders in line. I think this is the contribution what I done I'm able to deliver based on the learnings from seminars or inspirations from people here. Last 3 days, what made me more interesting is that my mind is running that last 3 days, whoever we met, whoever is not around the KSTA, I think that is enough to solve the global problem. That is enough to solve the global problem. Because the execution is a challenge. When we finished our graduation, we thought that we know 98%, only 2% will go to the field, and 2% we can pick up. But gradually it so happened that we knew only 2%, 98% we had to pick up outside after the graduation. So the practical challenges outside is we'll have to look at 360-degree angle. Okay, when it comes to business outside or any See now today's and last 2 days subjects, I saw 17 key points to look at climate resilience. I was thinking what all we have done, what all we could do. I think we could do justice to 12 points. Then yesterday we saw there are 10 ways to mitigate the risk here. I think all the 10 ways we have already touched in my journey. Only thing, this event, this platform made me think that I can improvise, and I did not know that there is so much depth in this. We are only practical, and we only address the challenges based on market analysis. Now, when it comes to detergents, we use large-scale industrial detergents. We shifted to biodegradable detergents. Now, currently, last 3 months, we have found a solution where bioenzyme can replace the entire detergent. On industrial scale, we are successful. If that happens, imagine the impact on the nature. Next is, we use a lot of, we have been talking about fear. And to be interesting, we have been using briquettes, compressed agricultural waste on an industrial scale to generate industrial scale steam. We do not use diesel or any fossil fuel for generating steam, as steam is the lion's share of our OPEX. So we have been doing that. We don't use diesel, and we use generators only when power failure happens practically. Let's come to other points. We have converted our factories into solar panels. We don't have space. Whatever available, we need that. Now, 50 to 60% of our electricity bill is covered by solar energy. It is a highly energy intensive project, water intensive, labor intensive, capex driven, a lot of logistics driven. So all this put together, every point we are able to do something wherein future it has an impact on our society. The two more important points, we do serve all the institutions. It's a primarily B2B model. We process something like 50,000 garments a day from institutions. We do wash them and give it back. There are many points related to this, which can add a lot of value to nature. One, we successfully increased life of the fabric. Imagine the impact at the national inventory. We have increased about 30%. We tell outside 20%, because there is no reward for this work. None of these works are not rewarded by anyone. We do not believe in grants, we do not believe in subsidy. So any business plan, wherein I take my salary at the end, it may take 3 years or 5 years or 10 years. The day I feel that I can take small salary, then I am successful. That's a business plan I believe in. There is no failure for me. Means I do not believe in failure, because success can be delayed. Only your patience, time, how much effort you put in to realize your dream. It may take years. In one case, it has taken 10 years, but we never stopped it. So, keeping all this techno-commercial feasibility, the charity has to begin at home. Now, I come to microfibers and microplastics. Every fabric, now, majority of the fabrics are synthetic. Cotton or natural fibers are very less. They release a lot of microfibers. Every garment, when you wash, it releases something like 0.5 to 1 gram on an average. And everything is microfiber around. The seeds in which you are sitting are also microfibers. Okay? They emit, they release a lot of fibers. It gets into nature, air, water, soil. We are successful in preventing that go out of our side, because we recycle our own water, we reuse it back 100%. We recover only 85%, because 15% goes as process loss. Now, I have covered process-related contribution, water-related contribution, energy-related contribution, and fabric and detergents-related contribution. I do not know how to measure the carbon credit. day-to-day affection and love towards nature for future generation. It made us to look at each and everything. In that I was very firm. I am the initiator in that. Very firm that, no compromise on that. Tomorrow I don't want to go away with guilt. Better work on nature. Naturally, now the fruit is. This has been recognized by Japanese giants. Naturally, for all the contributions, what we have done, they started working on documenting the Kstacademy model. And now I have completed one. Second, the water recycling system. Now that will take care of, according to me, next 10 years, that will take care of entire global water problem. That's a kind of impact which is going to have. So this is again created by us with a patent from Japanese scientists. It took 8 years to arrive at POC. How many years? What is POC? Proof of concept. Can you imagine a small scale entrepreneurs or SMEs or individuals who are from villages, from poor family background, can come to a stage where they can have 8 years patience to arrive at one POC, which takes 3 years to prove that it can cater to any kind of rainwater. So it does ETP job, it does STP job, and nowadays I start saying some of the scientists will be me that the source water can be anything. Give me the rainwater, I'll give you drinking water. And I don't need the civil structure. So if Bangalore alone has 4,000, 5,000 civil structures, laying waste, this required certificates. Imagine national level impact. When we talk today, I realize that so much of cement and steel is adding to the menace. So much of civil constructions which are lying waste or as ETPs, as recycling units, they themselves are the pain. So this technology which we have arrived and we own the company we have created can take care of entire global water problem. Only thing, it has to be recognized at the right level. Now let me come to the manufacturing. We do manufacture. I am a biologist. We do manufacturing heavy duty industrial equipment. I have no connection to engineering, but we own that. I initiated that. We used to import a lot of machines from Europe, US. Decided that again it has to carbon its logistics, steel, and a lot of other parameters. We started manufacturing from Bangalore, aiming that we will export to the same countries where we were importing. We are successful. And we started selling it. Now let me come to the interesting part where we are connecting directly is that food, agri and food. In agriculture, I have worked from last 20 years in different parts, different pockets. Preferred farmers, and that we call it as back-end. In general, in business, we call back-end and front-end. So back-end, I did a lot of homework, arrived at organic, so-called organic and natural farming, and we arrived at that. We were successful to 1.5 decades. And now, in the front end, I have two initiatives. One is done by me, myself, the other one I am part of it. One is, we arrived at millet. Let me tell you why did I arrive at millet. Now currently we have millet, ready to cook and ready to eat product. In that, most interestingly, fermented and dehydrated idli and dosa batter as a powder with shelf life of 10 to 12 months without preservative. We started selling that. We started exporting that. In millets, attaining this, why millet? Why this? There are 3-4 points which struck my mind from many years. One, millet is a native species. It doesn't, as a common man, it was not earlier farmed, it doesn't require farming. Second, it doesn't take much water. It's a sturdy species. Third, it has amazing nutritional benefit. Then why one should not go for this? So these three are enough for me to work on that. It takes care of nature also, it takes care of health also, it takes care of the steadiness as a species, which can, with least water, it can keep growing. So this made me get into millet. All these simple points made me to venture into company. So all these are successful. In addition to this, in food, we have smart food protein. Means we have a company called Evolved Foods, wherein we have arrived at a texture of protein which is similar to non-veg. That's one part. Whether it is chicken or mutton or whatever, non-vegetarians, they wanted to have vegan meat, we have developed on that. There are vegetarian options also. This has attracted in terms of smart protein happening, the discussion happening around the world. These all I'm not trying to post here. I'm just trying to say that if you have the intention, patience, perseverance, integrity, if you wait for some time, whatever background you are from, you can attain it. Earlier we used to only look at profit. Now we should look at there is a profit in carbon credit also. Not just looking at bottom line in business. With this, I would like to say that any one of you, as on behalf of KSA, would like to know more or get some tips for success formula, I think on behalf of KSA, I'll take Ramesh's permission and you can contact KSA and I can contribute or add value to do any of you, whatever I can. Thank you, sir. Thank you.
I think it was really an eye-opener for all of us. Because usually we know an entrepreneur who starts single business and tries to develop expertise in the same business and expand it. But this man, amazing, in the sense he has diversified himself into various aspects, maybe on water-saving technologies, or maybe even residue, conversion of residues into sort of a usable products, and of course, using millets and all that. It's a wonderful, I would say, sort of a diversification which he has really taken up very seriously. And the thing which most interests is the bioenzymes, which can even replace the bitter things. In fact, I would say most of our waters are polluted with phosphorus, which is rich, especially in bitter wells. And that's the reason Bangalore, you see just in front of the Bangalore University, you see frothing of the water, which is because of this, the detergent pollution. And this is one thing which, and that means it's a huge contribution, not only for the country, even for the living of a normal human being. This is something really great, and I wish he will continue to do some more new good things, and for the benefit of the country and benefit of all of us. And let us give him a big round of applause. I know you have heard, especially I would say, from sky to, of course, from space to the minings, and of course, one more thing that I thought that he should really attempt is the KGF, the underground water storage. So if that can be converted probably into usable farm and use it for the millet production. In fact, millets are something which are very, they are called superfoods. Yeah. That is good, great. And this another thing is that, in fact, I know, ನಿಮಗೆ ಬಹಳ ಜನಕ್ಕೆ ವೈಶಂಪಾಯನ ಸರೋವರ ಗೊತ್ತಿರಬೇಕು. ಎಲ್ಲಿದೆ ಅದು? ವೈಶಂಪಾಯನ ಸರೋವರ ಮಹಾಭಾರತದಲ್ಲಿ ಕೇಳಿರ್ತೀರ. ಕುರುಕ್ಷೇತ್ರ ಅಂತ ಕೇಳಿದ್ರ? ಕುರುಕ್ಷೇತ್ರ ಹರಿಯಾಣದ ಹತ್ತಿರ ಕುರುಕ್ಷೇತ್ರ ಅಂತ ಒಂದು ಜಾಗ ಇದೆ. ಅಲ್ಲಿ ಅದೊಂದು ಸರೋವರ ಇದೆ. And I think that local government has done a wonderful thing. No, in fact, I'm telling you, it is about 400 or 500 acres of area. ಆ ಒಂದು ನೀರನ್ನ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಫಿಲ್ಟರ್ ಮಾಡಿ, it looks so clear and good, and you feel like jumping into the water and swimming. So ಅಂತ ಒಂದು ಲೇಕ್ ಅನ್ನ ಬೆಂಗಳೂರಲ್ಲಿ ಡೆವಲಪ್ ಮಾಡ್ತಾರೆ. Because Bangalore has lost the glory of lakes, and in fact all lakes are polluted 100%. So that is one thing probably I think Prakash, I will give you one more input for you to further look into it. I think that's a great thing. Probably you can study that, and such sort of a thing can be implemented on a pilot model here itself in Bangalore. Thank you very much. I think it was a great now we move on to, of course, we have there are successful entrepreneurs, space scientists, and geologists, and now we go to the academics, the science per se. Probably, I think Dr. Professor Ashok Hanjigi, I think he is there with us, and he is very popular in this group because all his students are here. So I request him to maybe give his impressions on this panel. Thank you.
Very dignified Chairman, respected panelists, our dignitaries of the dais, including our organizer, Dr. Ramesh. First of all, let me congratulate you all for conducting such a wonderful event. The climate condition of the planet, condition of the atmosphere, weather, these phenomena have changed regularly since the inception of this year. 4.6 billion years have passed up. But much has been seen on the earth. Many things have fallen. The light has come, the light has gone. Many more mass extinctions we have seen. Most 5 mass extinctions happening. The thing is that the last few decades, if you take, the climate change, it happens because all ecological processes, biological processes, geological processes that are operating in an open air. One side you have a temperature from the sun, other side you have geothermal energy from the inside, and both they are interacting, they are having a lot of changes on the Earth's surface. You may have seen the Earth works like a system. There are so many systems. We have atmospheric system, we have a hydrologic system, we have a biosphere, we have atmosphere. All these, they work individually, independently, they also interact with each other. They are systematically running so that we are all existed over here. So now what is happening? The earth has made so many wonderful landforms. Like if you see, the earth has created so much highlands, mountain system, chain of mountains. On the side we have plateaus, we have plain lands, we have coasts, we have valleys. We have beautiful structure. But these structures are disturbing these days. Since humanity come into being on the earth's surface, but recently has come, but has damaged in a big way. The intervention, what Dr. Sangoma said, mining, entirely changed the earth system. You see, almost continents we have deforested. 20 millions of forested area we have taken out every year. Almost 1/4 of the agricultural land we are converting into barren land every year. So things are changing very fast. Due to this, somehow we are applying many technologies. We are still surviving. If you go back, there were used to be so many pandemic, viruses, so many diseases. There used to be huge population wiped out due to natural disasters or cultural disasters. But these days, even big disaster, biological disaster happened very recently. Even most of the people here survived. Because we have a technology, we have a new methods. But what about animals? What about the organisms that are existed all over the world? In a sensitive ecological system they are living in. The most of the animals or organisms, they have only 3 ways left out. Due to this change, climatic change, one thing is they have to adapt. Second one is they have to vacate the place, the new places they have to find out. To to survive. The next option left is perish, wipe off. So these are the only three options they have got. Since the human, we need to do a lot of. See, there should be very good relationship between environment and human. There should be positive relationship between human and environment. That we need to understand. That's why resilience, we need to develop a resilience community, resilience farmers, resilient poor. So how we can do this? So I'll come to some kind of recommendations later, 2-3 recommendations. So number one is such kind of things, capacity building programs are to be conducted. So that we need to understand ourselves, how these systems, the ecosystem services, what our chairman was explaining, those things, understanding is most important. Once we understand, we have a respect about them, we start saving them. The capacity building programs are most important. Those things are to be conducted regularly, not for the only students and expert members or college or university staff. Even at local level for public at large, these are most important. The second, the recommendation what I do from this podium is that most of the universities, colleges, this kind of climate change, climate resilience, sustainable development, they should be adopted in the curriculum. The most of our curriculum should come out with the most important methodologies to face the threat we are facing by the climate change. So this is most important. Another thing is that when you come to the Bangalore city has been expanded without any scientific way. So cities, population, city vehicles, they are increasing every day, every year. So what is to be done? If you look at some of the cities which I listed in Australia, like Brisbane, Sydney, Melbourne, Adelaide, they have been developed in such a way that they have so much open spaces. Even in downtown also we can see some greenery. Even China is also coming up with so many green buildings. Spawn city concept they have adopted these days. Such a spawn city concept which can hold a lot of water whenever there is raining. It can intercept a lot of rainwater. All these things we can think of. The cities, major cities have to adopt such kind of spawn city concept. Another important thing is the coastal zones, the mountain systems, they need to be preserved, they need to be saved. If you take an example of the Western Ghats, it is acting like a sponge. When it rains, lot of water will be stored over there. And maybe next another 3-4 months, the water will be percolated very slowly and we get in the form of spring, and later those springs convert it into small sand or tributaries, then convert it into river, then we get rivers through like Kaveri, Godavari, Ganga, something like that. But what we have done, we have removed them totally, we have changed their courses. Most of the rivers are not reaching those things these days. So such a kind of human interventions will happen. That's why most of the highlands, coastal zones will need to be, sustainability will need to be. With this, I thank the organizers for bringing me about.
I think it was a sort of giving motivation for learning. So that's what the academics means. So here, I really mentioned the curriculum should have all these issues of sustainability, climate change, climate resilience, whatnot, and including, I would say, detailing some of the natural resources. Probably one thing is the wetlands of India, and then the mountains, and the Ghats, and the Himalayas. These are supposed to be not touched. If you touch it, or if human intervention takes place in a much bigger way, then probably we will have a lot of issues and concerns as well. Of course, nothing must do it, but all the same, these are the requirements for us to carry forward. So thank you very much, sir. Thanks for your good presentation. Now I think seen many things in her life as well as an organizer, as a professor, as a teacher, and whatnot. I think Dhanashree has been there everywhere, especially Bangalore University. So for those who are dealing with animal sciences and fisheries and all that, she was the leader. So I always, she and of course Dr. Reddy was there. Both of them worked very, very hard for improving science. I request Madam on behalf of all of you to give her.
Thank you, Dr. Vasu. On the dais we have a very eminent fishery scientist who is now an educational manager. There's a space scientist, there's a mineralogist, there is a GIS specialist, and of course there is a, I would call him not an entrepreneur, a solopreneur, because I think he started it alone. He started it as a solopreneur, and he's a successful entrepreneur today. And they have all given their viewpoints about climate resilience and sustainability. Last 3 days we have been hearing climate, resilience, development and sustainability. The youngsters who are here, who are in the learning phase, I have always been only a teacher, so I will give you a little bit of an advice. All of us find ourselves today in a VUCA environment, a VUCA world as a body. V standing for vulnerability, U standing for very ambiguous changes, and there are complex environments, and then it gives us an idea that the life of Earth and the life of living organisms has always been cyclical. Extinctions have been there, and we always talk about the resilience and the development and sustainability. We never talk about regeneration. Earth has had its maximum regeneration whenever it was called for. Earth even changes a little bit of its axis as it goes around the sun, changing its axis so that that kind of a regeneration happens in the Earth as a planet and the only life support system as we know as of now. I personally believe that 14 and odd special lectures that were arranged by Dr. Ramesh and his clan have given us an insight into what needs to be done in future. I personally believe that future is now. There's nothing like waiting for something to do tomorrow, but we have to start with today. So each one of us, if we are able to contribute in terms of a responsible way of doing things, be it the environment, be it an engineering situation, or be it a technology, we do know now that there are these barriers have been now removed. You just have people from fisheries going into entrepreneurship, educationists becoming entrepreneurs, and so many of them have different. I thought I was loading it. So I personally believe that each one of you youngsters and the faculty members who have participated in 3-day seminar, I think there is a lot of takeaway for you from this seminar and this workshop. And I personally believe that each one of you, if we are able to understand our own responsibilities problem-based learning and turn into a profession-based learning and finally practice-based learning, I think there's no learning at all. So I again would like to endorse that this has been an excellent workshop in terms of what we could gain in a wide horizon of the climatic changes and sustainability and resilience that is called for. But I think the resilience will be for the youngsters. Don't get disheartened. As Ganesh Raj sir put it, nothing drastic is likely to happen in your lifetime. So look for positivity in your life, contribute positively, and today we always talk about, he also talked about an ecosystem and all the organisms to be put together in terms of, we call it as every species has its ecological significance in this biodiversity and Earth. So everybody must be respected, and that is the reason why we think in terms of today a One Health concept. The One Health concept talks about not just health of the Homo sapiens, but also the health of the plants, the health of the environment, the health of the animals, in a very holistic manner. So what we need to understand is that if we are able to lead a simple, holistic life, respecting not only the other human beings, but also other life on this earth, as well as the environment, I think we have done our job. And a lot of learning has to happen from home. So you have to be the torch bearers as people who are pursuing science. You have to be the ambassadors to carry the information to everybody that, selfless, responsible treatment to the environment and nature is what we need to promulgate in our coming generations. With this, I thank Dr. Ramesh and his entire group, Dr. Srinivas, and all of them who are the backbone of Dr. Ramesh, and the tireless organization that they are putting in the last 3 days. Everybody's wants in all ways were taken care of, and I'm sure all of you would have enjoyed, and we'll have a lot of grey matter to carry home in terms of what you need to do, how you need to take the science from everybody and become an entrepreneur like Mr. Prakash. And I would advise you that you put yourself in touch with me. No, I mean, I always say that first you have to be an intern, then you can become a specialist. So I think you should grab this opportunity of putting yourself in network to whomsoever you have been, no, not in fact, but whichever topic which has interested you, and then where you think your heart lies. So wherever your heart lies, please go ahead, and then please put yourself into a situation where you take home a lot of learning from this workshop. And I thank Dr. Ramesh for this opportunity given to me. And I'm locally here, so for whatever they call, I'm always ready to come and help. So that's the least and the thing that I can do as a reigning scientist and an aging scientist. Thank you very much.
Thank you very much, madam. I think it was a good summing up of things, and wonderful. I know she has that experience and it's a resilience. So that really brings in a lot of facts. All of us would say that. Madam made one point very clear: practice-based learning. So this is something which is very, very important for each one of us. Probably the Skill India, all these things, the startups, the stand-ups, all these things are aiming towards only this, and the new education policy as well. That's where we have been really addressing such a big issues for students. Unfortunately, I don't know, that new education policy is not well appreciated by some of the states, which is not a good, I would say, thinking, because it is done by experts like her only, with a lot of, I would say, ingenious thinking and the Basically, that is what was the whole concept. We don't want graduates just like that to come out of a college like the product, the input, the output is just a degree. No, it is not that. We want people who can become skill-oriented, who can get specialized, and who can become as a startup and as an entrepreneur as we go forward. I think that's where I think it's very, very important. Another very important point was that one world, one health. This comes, especially if you address the zero hunger and also the sustainability and agriculture. If these things are taken care, probably I think India will become very prosperous. I know it has been doing a lot of good things. Economically, we are becoming a strong country, but at the same time, still we are yet treated as a developing country, or still we are not in developed world. So that's where I think we need to look at things very, very seriously. And of course, as I said, I think nothing to worry for this generation. Always we should think for the future generation. That is the reason why we have this workshop. It's not that we can enjoy the whole earth and spoil it. We maintain, we sustain it, we safeguard it, and probably leaves something which is good for the future generation. That is the approach of this climate resilience and also the sustainability. So with this, thank you very much, madam, once again.
Don't just be human beings, be humane beings.
Human beings. Thank you very much, all the panelists. I think it was a great thing to listen to each one of you, and in your own field, I think it was really great. One just small, I would say, sort of an incident which has happened in life of some people, especially in Canada, ಅದು ಮೈನಿಂಗ್ ಬಗ್ಗೆ ಹೇಳ್ತೀನಿ. ಒಂದು ಏನು ಅಂದರೆ ಅಣ್ಣ ತಮ್ಮಂದರು ತಂದೆಗೆ ಹೇಳಿದ ಗಂಡು ಮಕ್ಕಳು ಹೆಣ್ಮಕ್ಳನ್ನ ಮದುವೆ ಮಾಡಿ ಹೆಣ್ಮಕ್ಳಿಗೆ ಯಾವಾಗ ಏನು ಕೊಡ್ತಾ ಇರಲಿಲ್ಲ, ಆವಾಗ ಏನು ಮಾಡಿದ್ರು, ಈ ಮಕ್ಕಳು ಬೆಳೀತಾ ಬೆಳೀತಾ ದೊಡ್ಡವರಾದರು, ತಂದೆ ತೀರ್ಕೊಂಡರು, ತಾಯಿ ಹೋಗಿದ್ರು. ಅವರಿಗೆ ಡಿವೈಡ್ ಮಾಡಬೇಕು ಪ್ರಾಪರ್ಟಿ. ಸ್ವಲ್ಪ ಈ ತಮ್ಮ ಅಣ್ಣ ಸ್ವಲ್ಪ ದಡ್ಡ ಇದೆ, ದಡ್ಡ ಅಂದರೆ ಸ್ವಲ್ಪ ಸಾಫ್ಟ್ ಆ್ಯಂಡ್ ಸೋಬರ್ ಆ್ಯಂಡ್ ಹಿ ಯೂಸ್ ಟು ಅಕ್ಸೆಪ್ಟ್ ಎನಿಥಿಂಗ್ ಓಕೆ. ತಮ್ಮ ಸ್ವಲ್ಪ ಚಾವು ಇಲ್ಲ. ಸೊ ಅವಾಗ ಏನು ಮಾಡಿದ, ಅವ್ರ ಜಮೀನಲ್ಲಿ ಒಂದು 8 ಎಕರೆ ಇರಿಗೇಟೆಡ್ ಲ್ಯಾಂಡ್, ಒಂದು 12 ಎಕರೆ ಡ್ರೈ ಲ್ಯಾಂಡ್. ಇದನ್ನು ಅವ್ನು ಹೇಳಿದಂತೆ, ನಮಗೆ ಇರಿಗೇಟೆಡ್ ಲ್ಯಾಂಡ್ ಕೊಟ್ಬಿಡಿ, ಅವ್ರಿಗೆ 2 ಎಕರೆ ಜಾಸ್ತಿ ಕೊಡಿ, 12 ಎಕರೆ ಅವ್ರಿಗೆ ಕೊಡಿ ಅಂತ. ಇವರು ಏನು ಹೇಳಿಲ್ಲ, ಓಕೆ ಆಯ್ತಪ್ಪ. ಕೊನೆಗೆ ಏನಾಯಿತು ಅಂದರೆ ಅಲ್ಲಿ ರಿಚ್ ಮಿನರಲ್ಸ್ ವರ್ಕ್ ಅವರು. ಸೊ ಮಲ್ಟಿ ಗ್ರೈನ್ ಗ್ರನೈಟ್ಸ್ ಅಂಡ್ ಅದು ಬಂದು ದಿಸ್ಪೆಲೋ ಯಾರು ಗಡ್ಡ ಅಂತ ಅವನಿಗೆ ಕೊಟ್ಟಿದ್ದ 12 ಎಕರೆ, ಹಿ ಬಿಕೇಮ್ ಮಲ್ಟಿ ಮಿಲಿಯನರ್. ದಿಸ್ಪೆಲೋ ವಾಸ್ ಸ್ಟ್ರಗ್ಲಿಂಗ್ ಇನ್ ದ ಫೀಲ್ಡ್. ಸಿ ದಿಸ್ ಇಸ್ ವೇರ್ ಐ ಥಿಂಕ್ ದ ವೆಲ್ತ್ and how actually it gets value during different phases of its life. It is something. ಹಾಗೆ ಹೇಳ್ತಲ್ಲ, ಬಟ್ ಇಲ್ಲಿ ದ ನೇಚರ್ ರೀಜನರೇಷನ್ ಅಂತ ಮೇಡಮ್ ಹೇಳಿದ್ರಲ್ಲ, ಅದಕ್ಕೆ ಒಂದು ಇಟ್ಸ್ ವೇರ್ ಐ ಥಿಂಕ್ ನಾವು ಹಿಯರ್ ಟುಡೇ. And if there are any questions from anybody or any one of us, absolutely, we will be very happy to respond, clarify as far as possible. If we can't clarify, we will give you somebody who is expert in such fields also. There is nothing to do. If you have any questions, please, you are free to raise your hand. ಅದು ಎರಡು ಥಿಂಗ್ಸ್ ಇರುತ್ತೆ. ಕ್ವಶನ್ ಕೇಳಿಲ್ಲ ಒಂದು, ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂತ ಒಂದು, ಇಲ್ಲ ಅಂತಂದ್ರೆ ಎಲ್ಲ ಅರ್ಥ ಆಗಿದ್ರೆ ನಾವೇನು ಮತ್ತೆ ಕೇಳೋ ಆಗಿಲ್ಲ ಅಂತ.
Once the programs are over, after that we also go relax. So what we like students or ourselves faculty members and all, what should be the common man's role in day-to-day life, so that we take up this on air.
As an educationist, I would say that probably I think our responsibility doesn't end once we attend the conference or once we go home and watch. Continues to be there. That's what is called the resilience part of it. We need to look at things in the, as was said by Madam, the practice-based learning. So this how we can improve upon in our life. It is just not the students alone, even the teachers. We need to do and try to get into that and try to see how best we can improve upon. What is happening today, unfortunately, in the universities is that the PPT-based culture has come. The digital, we call it as a digital learning process, but they will make PPT which will be used for 10 years. So this is not the way. Look at the PPT and understand each one of the words and try to improve upon the present day context. Then yes, you become a good teacher. And the students also like that. You need to really be, once you get interested in some area, try to network those. Not necessary that your teacher only should tell you. There are many people, many authors, many scientists who give you a lot of information. I would say here, I had a university eventually which was 100% displaced. In fact, even if my student is in the outside world, he can always source the books from my library. That we maintain. And that part, I would even say here, if they are not really understanding things, they will write to us, we will refer to the concerned expert, and he will clarify. See, this is what, that means it's a practice-based learning. You need to learn. Professional learning is different than practice-based learning. If this can be followed, that is the reason I said the skill development. It's a never-ending process. Skill is something which is just like it doesn't come. An ordinary agricultural labor has a wonderful skills than a professor who is working in a university of the same field. So this is where I think we need to learn from each other. Take it forward, and probably I think you will be the best, I would say, in terms of addressing the issue, or also in terms of your own personality development. That would help us. So, good number. I think I missed it.
There were three loves. Love of learning, love of learner, and the third love is to bring the first two together.
I think that's a good thing. In fact, I am happy that you raised that issue. This is something which is required by each one, not only you, every one of us. You need to really impact such qualities, then definitely you will become a good learner. Any other question? If there is anybody to contribute to this question? Number one, from the last 3 days, no doubt it was one of the wonderful conference. Dr. Ramesh sir and I think that was a wonderful one. Hats off to them. Once your 18 days, in fact, I want to tell you, what is there in our industry, I tell you. But whenever you attend any conference and seminar, you have to make every paper summary note. Number two, what you have learned from that. Number three, how you are going to help your institute by this one, or your industry. Number four, how it is going to help your career further. And number fifth, again, what type of project you are going to bring up, further research that you are going to bring up, or that is fund is available in the government. Ministry of Mines, just I am telling you, last week only I advertised a big science and technology project for the industrial application. Anybody is interested, they can apply and they can contact me. Just I am giving you the 3 topics for the research. Number one, water I told broadly, mine waste I told, and solar I told, and bricks and all the things for civil. There is enough scope for doing the works and all the things. If you make, everybody should make a summary of this one. Otherwise, only one day, today you will remember, handover will be there for 24 hours. Afterwards, you will forget you will be works. But that, thank you very much, sir. We are again thankful to all of the artists for this wonderful. But we need this opportunity. Thank you. I think if no other questions are there, I will hand over the mic to the organizers. And let me also especially thank the organizers, spearheaded by Dr. Ramesh, and also Srinivas, and many others. And Vijay Kumar has been a complaining person here, and I never expected him to do that because he is in City. So he is not part of. Oh, one of them. Okay, that's fine. So, and all the other, I would say, the support staff, especially I would say the food, part of it, whoever has taken care, I think was wonderful. So, if food is good, everything will be good. That's what I think you always, especially in conferences. That's not very good. I know that's a great thing, and all the best for each one of you when you go back. And be independent. So that is something which is very, very important for each one of us. So all the very best. Thank you very much, and wish all of you have a lot of messages to take home. Try to munch over that and do whatever best you can. All the best. Thank you.
One minute. So thank you very much, sir. Respected panel members. I think they have ignited the young minds. So because you people are future scientists, I wish many of you have to occupy stage like this in future and give a preach to youngsters. So because all are stalwarts in their respective field, starting from entrepreneurs to in their respective research. So thank you very much. With this, I would like to request all the panel members to receive a token of appreciation from KSTA, and I request Dr. Ramesh and others to do the honor. Dr. C. Vasudeva, sir. Okay, madam. Ladies first. Dr. C. Vasudeva, sir. Dr. Ganesh Raj, sir. Professor Ashok D. Shri K.V. Prakash, sir. And Dr. Prabhakar Sangurmat, sir. Thank you very much for receiving the honor, sir. Thank you, and you can occupy the seats. And thank you, Dr. Ramesh, sir, for honoring them. And meanwhile, in a short while, valedictory function will start. I know many students are waiting for certificates. So after valedictory function, we have a group photo. Please don't go, okay? After valedictory function, we'll have a 1 minute photo, group photo, and then you can discuss. Now, Dr. Noor Samad sir will take over the charge for valedictory function. Thank you.
ದೈವಕ್ಕೆ ಶರಣು. ಏನಾದರೂ ಸಮಥಿಂಗ್ ಏನು ಸ್ವಲ್ಪ ಹೇಳಿ ಅಂತಿದ್ರು, ಏನು ಹೇಳಿ ಅಂತ ನನಗೆ ಅರ್ಥ ಆಗ್ತಾ ಇಲ್ಲ. ಸರ್ ಹಾಡಿಲ್ಲ ನನ್ನ. ಥ್ಯಾಂಕ್ ಯು ಸರ್, ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್. ಸರ್ ಹೇಳ್ತಿರೋದೆ ನಾನು ರಚಿಸಿರುವಂತಹ ಕೆಲವು ಚುಟುಕು ಅಥವಾ ಕವನ ವಾಚನ ಮಾಡಿ ಅಂತ ಪ್ರಾಯಶಃ ದಟ್ ಐ ಕ್ಯಾನ್ ಡೂ. ನಮ್ಮ ತಂದೆ ಒಂದು ಹಾಡು ಬರೆದಿದ್ರು ಸರ್ 25 ವರ್ಷದ ಹಿಂದೆ. ದಟ್ ಹ್ಯಾಸ್ ಕಮ್ ಟ್ರೂ ನೌ. ಐ ಥಿಂಕ್ ವಿ ಕ್ಯಾನ್ ಸಿ. ಅದು ಒಂದು ಪಲ್ಲವಿ ಮಾತ್ರ ಹೇಳ್ತೀನಿ, ಆಮೇಲೆ ನನ್ನ ಒಂದು ಕೆಲವು ಚುಟುಕುಗಳನ್ನು ಹೇಳ್ತೀನಿ. ಮಾನವ ಓ ನವ ಮಾನವ, ಬರೀ ಸ್ವಾರ್ಥಿಯಾದಿಯಲ್ಲೋ ದಾನವ, ಕಾಡಿಗೆ ಕೊಡಲಿ ಇಟ್ಟು ಬೋಳು ಮಾಡಿದೆ, ವನದೇವಿಯ ಮೇಲೆ ಅತ್ಯಾಚಾರ ನಡೆಸಿದೆ, ಮೋಡ ಚೆದುರಿದೆ ಮಳೆಯು ಹಾರಿ ಹೋಗಿದೆ, ಬೆಂಕಿ ಬರಲಿದೆ ಭುವಿಗೆ ಬೆಂಕಿ ಬರಲಿದೆ ಅಂತ ಹೇಳಿದರು. ಬೆಂಕಿ ಬಂದ್ಬಿಟ್ಟಿದೆ ಇವಾಗ. ಆಮೇಲೆ ಏಡ್ಸ್ ಬರಲಿದೆ. ಈ ಥರ ಪ್ರತಿ ಚರಣದಲ್ಲೂ ಈ ಥರ ಒಂದು ಇದು ಹೇಳಿದ್ರು. ಎಲ್ಲ ಆಲ್ ದ ಎಫೆಕ್ಟ್ಸ್ ಆಕ್ಚುಲಿ ವಿ ಆರ್ ಗೆಟಿಂಗ್ ಇಟ್ ನಾವು. ಸೊ ಇದ್ರ ಜೊತೆಲಿ ಅವರು ಎಲ್ಲ ತಯಾರಿ ನಡೆಸ್ಕೋಬೇಕಾದ್ರೆ ನಾನು ರಚಿಸಿರೋಂಥ ಕೆಲವೊಂದು ಚುಟುಕುಗಳು ಹೇಳ್ತೀನಿ. ಮಾತು ಮೌನ, ಚುಟುಕುವಿನ ಶೀರ್ಷಿಕೆ ಮಾತು ಮೌನ. ಮಾತು ಬೆಳ್ಳಿ, ಮಾತು ಚಿನ್ನ, ಮಾತು ಮುತ್ತು, ಮಾತು ರತ್ನ, ಮಾತು ವಜ್ರ ವೈಡೂರ್ಯಗಳ ಹಾರ, ಮಾತು ಸಪ್ತ ಸ್ವರ ಅಷ್ಟೈಶ್ವರ್ಯಗಳ ಹಾರ. ಹಾಗಾದರೆ ಮೌನ? ಮೌನ ಈ ಹಾರಗಳ ಅಂತರಾಳದ ದಾರ, ಮೌನ ಈ ಹಾರಗಳ ಪೋಣಿಸಿರುವ ದಾರ, ಮೌನ ಈ ಹಾರಗಳ ಭಾರ ಹೊರುವ ಸರದಾರ, ಸರದ ದಾರ. ಮಾತಿಗಿದ್ರೆ ಮೌನ ಹೀಗಿರುತ್ತೆ. ಈ ನಮ್ಮ ಕಣ್ಣುಗಳ ಬಗ್ಗೆ ಒಂದು ವಿಪರ್ಯಾಸ ಇದೆ, ಅದ್ರ ಬಗ್ಗೆ ಒಂದು ಚುಟುಕು ಬಂದಿದೆ. ನಮ್ಮ ಕಣ್ಣುಗಳ ಬಗ್ಗೆ ಜೊತೆಯಲ್ಲೇ ಜನ್ಮ ತಾಳಿದ ಅವಳಿ ಕವಳಿಗಳು, ನಿಷ್ಪಕ್ಷಪಾತ ಕಾರ್ಯ ನಿಷ್ಠೆಯ ಅನುಕರಣೆ ಬಿಂಬಗಳು, ಅದ್ಭುತ ಸೃಷ್ಟಿಯ ವಿಸ್ಮಯ ದೃಷ್ಟಿಯ ಹುಟ್ಟು ಸಾವಿನವರೆಗೂ ಜೊತೆಯಲ್ಲಿದ್ದರೂ ಮೂಗು ಮಹಾಶಯನ ತಡೆಗೋಡೆಗೆ ಪರಸ್ಪರ ಸಮಕ್ಷಮ ಒಬ್ಬರನ್ನೊಬ್ಬರು ನೋಡಲಾರರು. ಪ್ರಪಂಚನೇ ನೋಡ್ಬಿಡ್ತವೆ, ಇಲ್ಲೇ ಇದೆ ಅರ್ಧ ಇಂಚು, ಇದು ಈ ಕಣ್ಣಿಗೆ ನೋಡಿದ್ರೆ ನೋಡೋಂಥ ಐಟಮ್ಗಳಾದ್ರೂ ಅದು ವಿಪರ್ಯಾಸ. ಹಾಸ್ಯಕ್ಕೆ ಒಂದೆರಡು ಚುಟುಕು ಹೇಳ್ತೀನಿ, ಅಪಾರ್ಥ ಅನ್ಯತಾ ಭಾವಿಸಬಾರ್ದು. ಪ್ರೇಮ ವಿವಾಹ, ಇದಕ್ಕೆ ನಿಮಗೆ ಖುಷಿಯಾಗುತ್ತೆ ಇಂಥವೆಲ್ಲ ಹೇಳ್ತಾ ಇದ್ರೆ. ಪ್ರೇಮ ವಿವಾಹ. ನನ್ನ ಪ್ರೇಮ ಪತ್ರಗಳ ಪ್ರಭಾವಕ್ಕೊಳಗಾದವಳು ಮದುವೆಯಾದದ್ದು ಯಾರಿಗೆ? ನನ್ನ ಪ್ರೇಮ ಪತ್ರಗಳ ಪ್ರಭಾವಕ್ಕೊಳಗಾದವಳು ಮದುವೆಯಾದದ್ದು ಯಾರಿಗೆ? ನನ್ನ ಹಕ್ಕು ಕಿತ್ಕೊಂಡು ವಿಳಾಸದ ದಿಕ್ಕು ಬದಲಾಯಿಸಿದ ಮಧ್ಯವರ್ತಿ ಪೋಸ್ಟ್ಮನ್ಗೆ. ಮರಣೋತ್ತರ ಸತ್ಕಾರ ಅಂತ ಒಂದು ಕವನ ಇದೆ, ಅದೊಂದು ವಾಚನ ಮಾಡಿಬಿಡ್ತೀನಿ. ಮರಣೋತ್ತರ ಸತ್ಕಾರ. ನನ್ನೊಡನೆ ಒಂದು ಹೆಜ್ಜೆ ಇಡದ ಜನ, ನನ್ನೊಡನೆ ಒಂದೂ ಹೆಜ್ಜೆ ಇಡದ ಜನ ನ ಸತ್ತಾಗ ನೂರಾರು ಹೆಜ್ಜೆ ಇಡ್ತಾರೆ. ಹರಕು ಬಟ್ಟೆ ಹರಿಕಾರ ನನಗೆ ಶುಭ್ರ ಶ್ವೇತ ವಸ್ತ್ರ ಉಡಿಸ್ತಾರೆ. ಒಂದೂ ನಿಮಿಷ ಮಾತನಾಡದ ಜನ ಈಗ ಗಂಟೆ ಅಳ್ತಾರೆ. ಯಾವ ಉಡುಗೊರೆ ಕೊಟ್ಟಿರದಿದ್ರೂ ಬಗೆ ಬಗೆಯ ಹೂಗಳ ಸನ್ಮಾನ ಮಾಡ್ತಾರೆ. ರಸ್ತೆ ಚರಂಡಿ ಬದುಕಿದ್ದ ನಿರಾಶ್ರಿತ ನನಗೆ ಪ್ರಶಾಂತ ಸ್ಮಶಾನ ಮಹಲಿನಲ್ಲಿ ಮಲಗಿಸ್ತಾರೆ. ನಿತ್ಯ ನಿರ್ವಹಣೆ ವಿಶೇಷ ರಕ್ಷಣೆಗೆ ತುಂಬು ಕಾಳಜಿಯಿಂದ ಮಣ್ಣು ಮಾಡ್ತಾರೆ. ಗಂಧ ಸುಗಂಧ ದ್ರವ್ಯಗಳ ಆರೈಕೆ ಮಾಡ್ತಾರೆ. ಹಾಳಾದ ಜೀವನನ ಹಾಗೇಕೆ ಸಾಗಿಸ್ತಿದ್ದೆ, ಹಾಳಾದ ಆ ಜೀವನ ನಾ ಹಾಗೇಕೆ ಸಾಗಿಸ್ತಿದ್ದೆ. ಸಾವು ಇಷ್ಟೊಂದು ಸುಖ ಸುಗಮ ಸಂಭ್ರಮದಿಂದ ಐತೆ ಅಂತ ಗೊತ್ತಿದ್ದಿದ್ರೆ ನಾನು ಯಾವಾಗಲೂ ಸಾಯ್ತಾ ಇದ್ದೆ. ಸಾವಿಗಿಂತ ಸುಖ ಇನ್ನೊಂದು ಯಾಕೆ? ಇಂಥ ಸಾವಿನ ಸುಖ ಪಡೆಯೋಕ್ಕೆ ಕೇವಲ ಒಂದೇ ಜನ್ಮ ಸಾಕೆ. ಎಲೆ ಮನುಜನೇ ನಿನ್ನಂತರಾತ್ಮದೊಡನೆ ನೀ ಬದುಕಲು ಕಲಿ. ಆತ್ಮ ಬಿಟ್ಟು ನೀ ನಡೆದರೆ ನಿನ್ನಾತ್ಮಕ್ಕೆ ನೀನೇ ಬಲಿ ತಬ್ಬಲಿ. ಅರ್ಥ ಮಾಡ್ಕೊಂಡು. So with this, we have come to an end since 3 days of climate resilience and sustainable development. I hope you must have enthralled with a beautiful, knowledgeable lectures with eminent personalities over here. So first of all, to begin with this valedictory function, I would request Dr. Anand, Scientific Officer, Karnataka Science and Technology Academy, to welcome the delegates and gathering, sir, please.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. We are at the end of this three-day conference. Today's valedictory function is presided over by Professor G.S.K. Swami, Dean and Professor and Head Department of Fruit Science, University of Horticulture Sciences, Bagalkot. Professor GSK Swami earned his bachelor's degree in horticulture, master's degree in pomology and PhD degree in horticulture from University of Agriculture Sciences, Bengaluru. Professor Swami has over 26 years of experience, has guided 25 masters and 4 PhD degree students. Sir has published 98 research papers in national and international journals, 19 research notes, 38 popular articles, 2 extension bulletins, 2 books and 10 chapters in books. With this brief background, I welcome Professor GSK Swami on behalf of KSTA and on behalf of all of you. In today's program, valedictory address will be delivered by Professor L.S. Shashidhara. Professor L.S. Shashidhara did his undergraduate and postgraduate studies in genetics and plant breeding at University of Agriculture Sciences, Dharwad, and holds PhD degree from University of Cambridge, UK. Professor Shashidhara has significantly contributed to the cancer research and scientific education in India. As founding academic member of IISER Pune and Ashoka University, he played a significant role in their growth. Sir has been instrumental in establishing both the Indian Cancer Genome Atlas and Pune Knowledge Cluster, which serves as a platform for collaborative cancer research and multidisciplinary efforts aimed at addressing health, water, environment, and sustainable mobility issues. Professor Shashidhara has served as a Vice President of Indian National Science Academy and Secretary General of the International Union of Biological Sciences. He is currently the President of IUBS, the first Indian to be elected in its 100 years of history. He has been awarded the prestigious Shanti Swarup Bhatnagar Prize for Science and Technology and the J.C. Bose National Fellowship and has been elected as EMBO member. In addition to his significant contribution to the research, Professor Shashidhara has also been involved in promoting science education. He has worked with Ministry of Education and Training, high school and undergraduate teachers in adopting inquiry-based teaching methods, organized several career workshop for scientists in science journalism, science policy, climate education, administration and management, and served on board of India Biosciences, reflecting his commitment to the life sciences research community in India. He is currently steering an international project on climate change education. During COVID-19 pandemic, Professor Shashidhara has been actively working to mitigate the impact in Pune city and also across India. His leadership in building institutions and communities, promoting science education and contributing to the combating pandemic's efforts have significantly impacted Indian science and society. We thank you, sir, for accepting our invitation to give valedictory address. I welcome you on behalf of KSTA and on behalf of all of the participants. We have with us Dr. D. Prabhuraj as chief guest of this function. Dr. Prabhuraj has bachelor's, master's and PhD degree in agriculture from University of Agriculture Sciences, Bengaluru. He has more than 25 years of experience as a research scientist. He has executed more than 100 projects on remote sensing, GIS and photogrammetry applications related to natural resource and infrastructure management, sponsored by state and central government departments. As mission director, successfully implemented Karnataka GIS, commonly called as KGS, the flagship program of Government of Karnataka. The program involved generation, updation of geospatial database of natural resources, infrastructure, assets of government departments, etc., and developing web-based GIS decision support applications for planning, implementation, and monitoring of developmental programs in the state of Karnataka, and which is also includes the capacity building in the field of remote sensing and GIS for the officers of the state government departments. He has guided for the project thesis 8 MTech Geoinformatics of Vishweshwara Technology Universities. Dr. Prabhuraj has awarded Certificate of Excellence by Cadastral Survey and Land Records, Hyderabad, for outstanding and extraordinary achievements for developing new techniques and research in the field of remote sensing, GIS, GPS, ETS, aerial photography to promote the advanced technology at national level in 2015. I welcome you to sir. In today's August gathering, we have many dignitaries. I welcome the chairman of panel discussion, Dr. C. Vasudev Pasar, former VC, NIFPM and UAHS Shivamogga, and panelist Dr. Ganesh Raj, former General Manager RRSC Bangalore, Professor Katresh Kuntala Madam, former Dean, Science and Head of the Departments of Zoology, Bangalore University, Professor Ashok D. Anjagi, Dean, Faculty of Sciences, Bangalore University, Sri K.V. Prakash, Founder and Director, EcoMold, Bangalore, Dr. Prabhakar Sangurmat, former Executive Director, Arti Gold Mines, Dr. Ramakrishna, former Director, JSI, Government of India, Professor Gangadhar, Professor of Horticulture. I also welcome all my colleagues and all those who are directly or indirectly involved. I extend a warm welcome to print and visual media. I also welcome Professor K.S. Nataraj, former Vice Principal, National College, Jayanagara, and our esteemed former member. I welcome all the delegates, participants, those witnessing in this program through social media platform for this valedictory function. Welcome, one and all.
Thank you very much, Dr. Anand, Senior Scientific Officer, KSTA. So, dear friends, we are glad to have our one of the chief guests over here, who himself actually has a deep interest in the field of science and technology. It's our pleasure to invite him here. I would request Dr. L.S. Shashidhara, sir, Director, NCBS, to share a few words on the valedictory address, sir, please.
Good afternoon to all of you. Ellargu namaskara. Thank you very much for inviting me for this, valedictory function. In fact, I should have attended at least some of the, sessions before coming for a valedictory function, which generally doesn't like, if I had to address without knowing what happened in the last 3 days. But anyway, I did get some information about the kind of lectures and deliberations, panel discussions that you had. So what I'll do is to sort of use my PowerPoint presentation, this is the one. Sort of in the context of climate resilience and sustainable development, and maybe I'll put some thoughts, right? And, this is, I'll use this. So, in a way, what we are trying to, achieve, because we are climate change as a problem, right? And climate change problem is created by us. Obviously, we have to solve this. Us means humanity created this. It doesn't matter, which part of the world who created this. Finally, all of us are affected. One of the major problems of the climate change is its impact is not the same across the globe. The cause could be the same, right? Let's say because of the carbon emission, the global warming is happening. And this global warming, its impact, it could be ocean acidification, sea floor raising, seawater levels raising. The earth is continuously in a dynamic state. Things are changing all the time. But what we have done in the last 200 or so years since industrialization is to accelerate this change. The rate of change is so fast that the life is not being able to adapt to these changes. As a biologist, as an evolutionary biologist, I'm sure all of you know, in the school you have studied evolution, is a process by which organisms adapt to changing conditions. Why do they need to adapt? Because the environmental conditions change, and that change is constant, is happening all the time, right? So, for two reasons. The physical parameters change for a variety of the dynamics of the universe, which will have an impact on the Earth, and so there is a change. The second is the change that is happening because of the very fact that the life exists on Earth. Any time when there is interaction, there is a change. The very fact that we have oxygen in the atmosphere is a product of the life on Earth, right? So in that way, there is always a continuous change. If, for example, there are more birds, they feed on insects, there is a less number of insects, perhaps less pollination, and that will affect the plant growth, certain kinds of plant growth, that will reduce the insect. Once the insect, the population goes down, the bird population has to come down because there is no food for them. So there is a continuous cycle of ups and downs of very different species and subspecies and populations in the living system, whole ecological system, and they need to continuously adapt. But this adaptation is a long-drawn process, depending on the life cycle. A bacteria may be able to adapt within few days because their life cycle is every 30 minutes or 1 day of new generation. For a mammal, like an elephant or a human or a crocodile, it may be, crocodile is not a mammal, the crocodile is, a reptile. For those long-living organisms, what I meant, right? It's 35 to 40 days a new generation comes. And adaptation is a genetic event, right? Every time DNA replicates, some new variations are generated, and those variations are the ones which basically keeps the population very diverse, and natural selection act on it. And this natural selection will basically help to the population to adapt, because there is sufficient variation in the population. That will help in adaptation to the new environmental conditions. But if environment is changing so fast, within a lifespan of an organism, it changes multiple times. There is no scope for adaptation using genetic method. Sometimes there is some physiological adaptation happens. So plants are very good in physiological adaptation, particularly trees. That's how they have been able to live for hundreds of years. There are some trees which have lived for a couple of thousands of years, right? And the redwood, trees in Sequoia National Park in US, there are trees which are 3,000 years old. They have been able to live that long because there is a physiological adaptation. That's not genetic level adaptation. Wherever we depend on genetic level adaptation, obviously we succumb to the climate change, and that's exactly what's happening. And we all depend on agriculture since civilization. Agriculture led to the civilization. And agriculture crops are all 3 months to 6 months to 1 year old. There are some, perennial crops. We can grow for 3 to 4 years, and every year you can take the harvest. But still, they will not be able to sustain the current level of climate change. This is where there is a primary immediate need to mitigate the climate change problem. There are two aspects to this. One is reduce the rate of change by making our life more and more carbon neutral. Second is already existing the problem, because it will last for another 30, 40 years, even if you make it completely carbon neutral today's life. That itself, people are saying, Europe, for example, only last week they came out with a declaration that by 2050, they make entire Europe carbon neutral. It's a commitment, statutory commitment for all the European Union countries. India, our Prime Minister announced last year that India will become carbon neutral in 2070, right? We are in 2023 now. And that means the rate at which we emit carbon may come down, but it will be still adding to it. And that means not only we need to adapt for the next 50 years, we also we had to understand how to be climate resilient, how to have a sustainable development goals for the next 100 years, 150 years or so. Given this, the next generation, I think I'll skip some of these things. So the next generation students, right, are the ones who need to really take this challenge on themselves. And unfortunately for you, we people who are older now, we created the problem and leaving behind the problem for you to solve, right? Sorry for that. At the same time, we have some responsibility and we have certain way of doing it, is educating you. It's not about educating you in genetics, evolutionary biology or climate science, is training you in problem solving ability, analytical ability, critical thinking, self-learning ability. Because the problems, we don't know how it's going to be manifested. With the 5 years from now or 10 years from now, we don't know how it's going to be manifested. And you, when you're looking for a professional career, you also don't know what kind of jobs will be there for you in 5 to 10 years from now, right? Or 10 to years from now. It's easier if you develop analytical ability, critical thinking, self-learning ability. That helps you to create your own professional career, create your own, an enterprise, and think of your own creative solutions to the problem of your time. Don't expect that today we can tell you how to solve a problem, because that problem doesn't exist even today. We don't know what kind of problem would come to you tomorrow. So our responsibility is to train you, and you hopefully will solve the problem, and you leave behind less severe problem for next generation, right? So if that happens continuously for next 20 to 30 years, or let's say 50 years, hopefully the world will be greener and more sustainable. Today's, what happened in the last 200 years, every year we added more problem and made the problem more severe, and it has become a stage where it's become extremely critical and very difficult to solve in one generation. It takes 3 to 4 generations to solve this today's climate change problem. But it is not all that of a disappointing or it's like a helplessness kind of a situation. The future is bright because science has developed many new ideas. There are new discoveries we have made, the scientists have made. We have better understanding of the world. We have better understanding of the interaction between the non-living and living entities. Within living entities, ecological interactions, we have better understanding. Because of which, we should be able to solve the problem more comprehensively. 50 years ago or 20 years, 100 years ago, when people were building dams, did know what kind of ecological damage, what kind of climate change problem it will create. But today we have better understanding. We know at least if we cannot solve today's problem, we should not make it more severe for the next generation. That level of understanding we have already come. Otherwise, we would not have all these discussions. 50 years ago, there was not even a single symposium on climate change problem, right? Climate change was never a problem. At that time was not a problem. Even when there was, for example, soil pollution was a problem, water pollution was a problem, air pollution was a problem, even 50 years ago, but it was not such severe that there would be large number of conferences and meetings. But today we are having that because we have a better understanding how to solve this, right? Just look at this. Science is global. Whether you study genetics, evolution, earth science, physics, chemistry, mathematics, it's global. There's nothing like Indian science or Western science or Japanese science. But the problems are local. So when you apply scientific knowledge to solve the problem, what we call as innovation, innovation has to be local. So that's why I've written, we have to be locally rooted when you solve the problem, but the way you solve the problem will be globally relevant because you are going to use the same scientific knowledge, and the way you solve your problem here may trigger some new innovation for elsewhere to solve the same problem, right? And when I say differently, within the country, we as India, we consider as one nation, but India is made up of more than 600 nations, right? Each in the context of climate change and its impact. There are so many different geoclimatic contexts in India, so many different socio-economic contexts in India, so many different agricultural practices in India. We can divide India easily into 600 different contexts in solving the climate change problem. So each one has to have its own innovative solutions. It has to be collaborative. It has to be based on the knowledge sharing. It cannot be done by one individual. It's not like a Newton or Einstein or Raman or Jagadish Chandra Bose, who whatever they discovered, some of them invented something like Bose also invented many new tools, but those are the days when one individual could do certain kind of work which was landmark. But the kind of problem we are doing, it has to be collaborative, it has to be multidisciplinary, it has to be, multi-institutional, multicultural, otherwise we'll not be able to solve this problem. And sustainability skills I already talked about is something what you need to, be learning all the time. Where everything that you do, you have to think about it, whether it is meet one of these sustainable, goals that is enlisted by the United Nations organization. There are certain kinds of skills you need to develop to obtain this. That's where your way to think, the way you act on any aspect of the sustainability, and that basically becomes part of your life, and it will be very interdisciplinary in the context. I'll just end with one example in which we are working on it. We initiated a climate change education project to bring climate science, its understanding, and ways to solve this problem locally across the world, across the discipline. It doesn't matter if you're a student of physics, you're a student of chemistry, you're a student of, let's say, computer science, history, economics, or even English literature or Kannada literature. Can we bring climate change topics in such a way that they are integrated seamlessly within the curriculum, and the pedagogical methods are used in such a way, I'll skip this. The pedagogical tools are, developed in such a way that it will not only help you to learn the climate science and its impact, and trigger innovation in your mind, how it can be solved, or how you can actually communicate to others what's the problem, a root problem, what are the ways one can be solved, because also outreach is important in this context. And the third is, in the process, you also develop some 4 elements of the learning outcome that I mentioned, which is also mentioned in NEP, New Education Policy: critical thinking, self-learning ability, and innovative skills, and analytical ability, right? And these 4 elements of learning outcomes also can be gained. The way we can do is, for example, it's called inquiry-based education, or research-based education, project-based education, experiential learning. You can have variety different kind of things, but it should be integrated with the curriculum. Otherwise, you may not show interest, right? Why would you show interest to learn something on climate science? Because you want to get 100 marks in your mathematics exam in 10th board. Idea is how we can actually help you to learn mathematics better, so that you can get your 100 marks in mathematics in the 10th board. At the same time, you also learn something about climate change. In the process, you also learn some analytical ability and so forth. That's the kind of tools we have developed, methods we have developed, and here's the snapshot of it. You can go to the website. It has a large number of lesson plans, teaching tools. That helps teachers to use digital teaching tools. It also has lesson plans worked out as a proof of concept, so teachers can develop their own lesson plans. Student can directly use this because there is a very clear method of how to learn certain topics in your own syllabus of any particular topic that you are learning. And then it also has multiple disciplines integrated. It has multiple teaching tools or learning tools integrated, like games or videos or some project-based learning and so forth. And we have conducted a large number of workshops across the world, more so in India, particularly a large number of them in India for teachers. And I would like to, collaborate with you to organize teachers training workshop, on climate change education integrated with the core curriculum and the syllabi. And also we are training teachers to develop their own lesson plans, the last 2 minutes. And for example, when we are organizing this teachers training workshop in Uganda, in Entebbe, the large number of teachers came from Uganda and nearby countries like Kenya, and they thought of developing their own lesson plan. One of them is Uganda, because of the climate change, the eastern part of Africa is also becoming more barren, losing its green coverage. And they wanted to quickly restore the degraded habitat. And one of them is what kind of plants you want to use. So in the classroom, you study plant physiology, C3, C4, camp, kind of different types of plants based on their, photosynthetic, biochemistry, right? And one of them is bamboo. Bamboo is basically, as an example, we always show for the CAM method of, carbon fixation. And bamboo is also fast growing, is climate resilient. Interestingly, bamboo can also be used for agroforestry, bamboo is also used as an economic product. In that context, they started growing bamboo in Uganda in a larger scale. And interestingly, they also turned out to be that bamboo shoots also good feed for mountain gorillas. And because of the loss of green coverage, mountain gorilla was considered as an endangered species, extremely critically endangered species under IUCN category. And turned out to be that bamboo helped in conserving gorilla population, and now it's increasing, like the way our tiger population is increasing because of the multidisciplinary effort to address the tiger problem. Similarly, they have addressed the gorilla problem. So we have, anyway, I'll stop here. Basically, what I'm trying to say is students today need to be more independent in identifying the problem and solving the problem, because everybody has to solve problem in their own way. Otherwise, we'll not be able to solve the problem of the climate change. While climate change problem has reached a stage, we cannot blame one or two individuals. We have to blame entire humanity for the last 200 years, everyone who lived on this earth and contributed to this. But the solving the problem also comes with everybody's responsibility. So I'll stop here. Thank you very much for this occasion.
Dharmo rakshati rakshataha. A protected dharma protects the protector. ಅಂದರೆ ನಾವು ಧರ್ಮವನ್ನು ರಕ್ಷಣೆ ಮಾಡಿದ್ರೆ ಧರ್ಮ ನಮ್ಮನ್ನು ರಕ್ಷಿಸ್ತದೆ. ನಮ್ಮ ಧರ್ಮ ಇಲ್ಲೇನು ಅಂತಂದರೆ ಒನ್ಸ್ ಅಗೇನ್ ಗೋ ಬ್ಯಾಕ್ ಟು ಪರಿಸರ ಪ್ರಾಣಿ ಪಕ್ಷಿ ಎಲ್ಲದನ್ನು ನಾವು ರಕ್ಷಣೆ ಮಾಡಿದ್ರೆ ಅದು ನಮ್ಮನ್ನು ತುಂಬ ಚೆನ್ನಾಗಿ ರಕ್ಷಣೆ ಮಾಡ್ಕೊಳ್ತಾ ಜೊತೆಲಿ ಮಡಿದಲ್ಲಿ ತೊಗೊಂಡು ಹೋಗ್ತಾ ಇರುತ್ತೆ. ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್ ಡಾಕ್ಟರ್ LS ಶಶಿಧರ ಸರ್, ಡೈರೆಕ್ಟರ್ NCBS, ಫಾರ್ ಯುವರ್ ವ್ಯಾಲ್ಯೂಯಬಲ್ lecture, sir. May I now take this opportunity to invite our Chief Guest of Honor, Dr. B.K. Prabhuraj, Director, KSR SAC, for the Chief Guest of Honor. Address, sir, please.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. Good afternoon. So respected dignitaries on the dais, off the dais, delegates, students and friends. It is an immense pleasure for me to be present here on the occasion of the valedictory function of the 3 days National Conference on Climate Resilience and Sustainable Development organized by Karnataka Science and Technology Academy. The impacts of climate change are becoming increasingly apparent through extreme weather events, rising sea levels, and other changes to our environment. In response, many communities and governments are working to build resilience and adapt to a new climate reality. But there are still major challenges ahead. Adapting to climate change means taking actions to prepare for, withstand, and recover from the impacts. This includes making infrastructure, agriculture, communities, and economies more resistant and able to bounce back from climate events. Many strategies can help, from planting drought-resistant crops to installing flood barriers. Resilient development takes this a step further by integrating climate adaptation into long-term planning and decision-making. This ensures that new projects and policies consider future climate risks and build in flexibility to adjust over time. Education, public health, and social safety nets also play a role in resilience. However, climate impacts disproportionately affect the world's poorest populations who have contributed the least to global emissions. This creates an equity dilemma for resilient development that aims to lift people out of poverty while protecting the most vulnerable. Limited resources and lack of information are also barriers. Moving forward, we must scale up financing for adaptation and resilience, especially for developing nations. New technologies and data can help us plan smarter and target strategies where they are needed most. Remote sensing and geospatial technologies are valuable resources to monitor the sustainable development goals and their corresponding targets and indicators. It provides unbiased observation and analysis. Moreover, geospatial information and technologies are particularly critical to strengthening urban and rural resilience, where economic, agricultural, and various social sectors intersect. However, there is still a gap between the tremendous potential of these technologies and the world of environmental decisions and policymakers. I certainly can say that this conference addressed the gap by providing various insights into technological usages and knowledge transfer for researchers, academicians, and administrators to assist them in making better informed data-driven decisions. Furthermore, the conference was engaging the youth towards the current practices of evidence-based decision-making. This conference also explored the use of geospatial technologies for building and improving the resilience of communities to climate change and disasters. The world is changing rapidly day by day. Sustainability and climate action have become critical priorities for individuals, organizations, and governments alike. To effectively address these challenges, innovative technologies are playing a pivotal role. One such technology is geographic information system, which offers powerful tools for understanding, analyzing, and managing spatial data. I hope that this conference has explored the various ways of GIS is being leveraged to drive sustainability efforts and take climate action. It is needless to say that throughout the world, geographic information systems are playing a central role in sustainability efforts by providing a comprehensive ecosystem for integrating and visualizing diverse environmental data. It enables stakeholders to make informed decisions by mapping and analyzing various sustainability factors. With GIS information on land use, biodiversity, water resources, and energy consumption can be overlaid on infrastructure assets and analyzed to identify parameters, relationships, and areas for improvement. One of the key applications of GIS in sustainability is the analysis of land cover data. KSRSAC has been generating up-to-date land cover data at large scales from time to time using satellite images and drone surveys for various purposes and applications. More than 800 GIS layers are readily available and usable for analysis and decision making. By utilizing this GIS areas suitable for conservation or restoration efforts can be identified. KSRSAC is providing support to the Department of Mines and Geology to monitor the mines in terms of the volume of mineral excavated and encroachment to prevent over-exploitation. So GIS also aids in the monitoring and management of protected areas, ensuring their long-term sustainability. KSRSAC has established a remote sensing-based automated forest fire alert and monitoring system to support the Karnataka Forest Department for forest fire management in near real time. So this helps to control forest fires, forest spreads, and damages very significantly in the last 4 years in Karnataka. KSRSAC has also created a remote sensing-based forest cover change alert system to monitor forest tree cutting, degradation, and encroachment, thanks to Indian, European, and US space agencies for their openly available satellite datasets.
Overall, GIS provides a powerful tool for understanding and managing sustainability factors. By leveraging its capabilities, stakeholders can gain valuable insights, identify opportunities for improvement, and make informed decisions to promote a more sustainable future. GIS leverages location intelligence for climate action. Karnataka has well-established and high-density telemetric weather stations and rain gauges throughout the state. Weather data received from these stations along with their locations will help to measure and provide actual weather conditions and forecast the same. GIS enables the mapping of flood-prone areas, allowing for the development of risk management plans and the implementation of measures to minimize the impact of potential flooding. Kstacademy has been doing flood inundation mapping, modeling, and damage assessment using remote sensing technologies to help disaster management. Additionally, GIS can identify suitable locations for the installation of renewable energy infrastructure based on solar and wind potential. Kstacademy has started to work with Karnataka Renewable Energy Development Department to provide them with suitable locations for establishing solar panels and wind turbines by analyzing solar radiation or wind patterns. So this promotes the generation of clean and sustainable energy for use. Thus, by integrating data from various sources, GIS aids in the development and evaluation of climate action plans. It enables decision makers to assess the effectiveness of emission reduction strategies, identify areas for improvement, and track progress towards climate goals. Karnataka is very keen to use the latest technologies to monitor climate changes, environmental impact assessments, and sustainable management. By harnessing the power of GIS, we can make informed decisions and take effective action to address the challenges of climate change. I hope that this 3-day national conference on environment, resilience, and sustainable development has created a fruitful impact on us. So thank you, one and all, and thanks for inviting for me this program. Thank you.
Thank you very much, Dr. K. Prabhuraj, for your insightful knowledge for the gathering, sir. Knowledge, sharing the knowledge is the first step towards the wisdom, and discussion with the eminent personalities is the first step towards the humanity. So now, I would request Dr. G.S.K. Swami, Dean College, Horticulture Sciences, College of Horticulture Sciences, Bangalore. Sir, ನಿಮ್ಮ ಮನದ ಸಿಹಿ ನುಡಿಗಳು ಅರಿಯಲು ಬಲು ಚಂದ, ಅಂತರಂಗದ ಅನುಭವ ಅರಿತವರಿಗೆ ಅಮೃತ. ದಯಮಾಡಿ ಈ ನುಡಿ ಪೀಠಕ್ಕೆ ತಮಗೆ ಅತ್ಯಂತ ಆತ್ಮೀಯವಾಗಿ ನಾವು ನಿಮ್ಮ ಒಂದು 2 ನುಡಿಗಳನ್ನು ಆಲಿಸೋದಕ್ಕೆ ಆಹ್ವಾನಿಸ್ತಾ ಇದ್ದೀವಿ ಸರ್.
ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. Good evening to all. Respected dignitaries on the dais, of the dais, delegates, participants, and media persons. I am honored to address the conference on climate resilience and sustainable development, a gathering that underscores the urgency of fortifying our societies against the impacts of climate change while fostering a future that is both environmentally sound and socially just. As we convene to discuss climate resilience, we acknowledge the increasing frequency and intensity of extreme weather events, rising sea levels, and disruptions to ecosystems. These challenges demand not only swift response but a proactive commitment to building resilience in our communities. Climate resilience is not merely a concept, it is a call to action. It requires a comprehensive and coordinated effort to protect our communities, infrastructure, and ecosystems from the unavoidable impacts of a changing climate. It is about fortifying our cities, ensuring food security, safeguarding water resources, and promoting adaptive strategies that empower communities to thrive in the face of adversity. Sustainable development is the key to achieving lasting resilience. Our vision must encompass economic prosperity, social equity, and environmental stewardship. We cannot strengthen resilience by sacrificing one for the other. Instead, we must embrace an integrated approach that harmonizes economic growth with the preservation of our natural resources. Investing in green infrastructure, renewable energy, and sustainable agriculture are essential components of building climate resilient societies. By incorporating these principles into our policies and practices, we not only mitigate the impacts of climate change, but also lay the foundation for a more prosperous and equitable future. Local communities are at the forefront of climate resilience efforts. Empowering them with the knowledge, resources, and tools to adapt to changing conditions is paramount. The resilience of a nation is a sum of the resilience of its individual communities, and we must support and learn from each other in this collective endeavor. International collaboration is equally critical. Climate change respects no borders, as our Dr. Shashidhar has told. So it is locally it is across the border. And the challenges we face are truly global. By sharing knowledge, technology, and resources, we can amplify our collective impact and accelerate the transition to a more resilient and sustainable world. In our nation, we are committed to fostering resilience at every level. We are investing in cutting-edge research, developing innovative technologies, and implementing policies that prioritize both environmental protection and economical growth. Our goal is not only to weather the storms of today, but to build a foundation that can withstand the challenges of tomorrow. As we embark on this journey, let us remember that building resilience is not just about surviving, it is about thriving in the face of adversity. It is about leaving a legacy of strength, adaptability, and sustainability for future generations. Together, let us rise to the occasion, committed to a future where our communities, our nations, and our planet emerge stronger and more resilient than ever before. Our chief guest, Dr. Shashidhar, has rightly said that climate change covers across the world and it is very fast. So from the last few decades, the climate change we observe is in a very faster rate. So measures to mitigate the effect necessarily include solutions that are locally rooted, but based on the global scale. Rightly said that think globally, act locally. So next generation people have a major role, especially more young generations are here. So students need to be independent because all the problems are different and the situation is different from location to location. So definitely we, the youngsters, have a right role in the future communities. And Dr. Prabharaj has mentioned about the importance of the GS and also the role of the institute. And also he has mentioned that our Indian agriculture is affected by, because India is mainly depend on the more than 60% agriculture based, and majority of our farmers are, the per capita land is very less. So whatever the measures to mitigate the climate change, so we have come across with the low per capita land availability, high input cost, and also the knowledge, less knowledge. So mitigate these. So you have to adapt the various activities across, starting from the selection of the multi-tolerant crops, maybe because stress tolerant, disease tolerant, and also adopting better water, nutrient, and other input use efficiency, and also precision farming and diversification of the crop. So these are very important. So by utilizing all this, and also nowadays there is shift in the agriculture because more women laborers are more involved. So there is a survey that in the agriculture, the 75% of women are contributing towards the major crop production, and 75% women labor is involved in the post-harvest management. Similarly, 90% women are involved in the fisheries, especially animal husbandry. So women has a major role in the agriculture. So I hope this three-day conference on the climate resilience has given a very good, fruitful discussions, and will carry the good message to the home and act according to the situations. So with this, I thank the organizers for providing me, presiding over this function. Thank you.
ಹುಟ್ಟಿದ್ದು ತಪ್ಪು, ನಾವು ಭೂಮಿ ಮೇಲೆ ಹುಟ್ಟಿ ಬಂದದ್ದೇ ತಪ್ಪು. ಬಂದದಕ್ಕೆ ಏನಾದರೂ ಸಾಧಿಸಿ ತೋರಿಸುವುದು ಒಪ್ಪು, ಒಪ್ಪದೆ ಹಾಗೆ ಕಾಲಹರಣಕ್ಕೆ ಬರುವುದು ಮುಪ್ಪು, ಮುಪ್ಪಿಗೆ ಒಪ್ಪಿಲ್ಲದೆ ದಕ್ಕೀತು ಖಾಲಿ ಕಪ್ಪೆ ಚಿಪ್ಪು. ನಂದೇ ಚುರುಕು. Thank you very much, Dr. G.S. Swami, for your presidential address, sir. Now it's open for delegates' feedback for 5 minutes. It's voluntarily. Anybody? We're running short of time, in fact. 5 minutes, it's open for the feedback now. You should address your name and then...
Good evening, respected dignitaries on the dais and dignitaries outside the dais, other professors and students. I am Dr. Sandeep Nayak, faculty, adjunct faculty in Mahatma Vadiraj Institute of Technology, Udupi. Also, I give lectures in another 2 institutions, that is Vivekananda College, Puttur, as well as MIT, Mysore. I came with my student who gave a presentation on the first day. He came from Mysore. And I thought that because I am almost 59 to 60 years now and guiding 4 students, and when we give a lecture to the class, to the students, usually we take more time. So here, at least when we sit for a long time, so we'll be knowing what will be the student mentality and whether we have to cut down the classes for the present generation and all. So I think coming to the matter, I say that it is doing right things is effectiveness and doing things rightly is efficiency. In the 2 words, if I want to say that, the KST under the guidance of Dr. A. M. Ramesh, so they organized the conference in an effective and efficient way, sir. Thank you very much. Dr. APJ Abdul Kalam said that learning gives creativity, creativity provides thinking, and thinking gives knowledge, and once we have a knowledge, definitely everybody will treat us great. So I think it may be a talk of Dr. Ayappan, or it may be a talk from Professor Honnegowda, or yesterday ecology on talk by Dr. V. Ramchandra, or many other experts on even mitigation and all, even the panel discussion and all. I think all the sessions were very good, right? A candle will not lose its strength by lighting another candle. So finally the outcome is, so whatever, isn't it? The research means it should be consistency, credibility and continuity, right? And isn't it? A candle will not lose its strength by lighting another candle means something kindling should be there here. When Hans-Peter Dürr got alternate Nobel Prize, he said that the future of mankind depends on cooperation and not competition. Let us cooperate, let us learn whatever we have done and do something good to them. Thank you for giving the opportunity. Thank you, Ananda.
Thank you very much, sir. Next delegate, please. Anybody? Oh, please.
Thank you. I'll be very quick and brief. My reflection on 3 days of conference on climate resilience and sustainable development is that I'm basically a physics student, a chemistry student who does a lot of wet lab things. And we know that climate change is the problem. But for students like us who are learning engineering subjects and pure science subjects, we just read a few lines about it and we concentrate more on our subjects. But this conference was so well curated that it allowed me to understand the depth of the problem that we are facing. And I'm very I'm very appreciative of all the members who have curated each and every talk. They were very well placed, and an opportunity for students like us was given to present our work as well as display our models, which was kind of tough to do. It's good to do a poster presentation or an oral presentation, but to bring out your research as a model was something I felt was challenging, and it's good exposure for me. And all the 3 days were really well spent, and food was really amazing. Thank you for that as well, and thank you.
ನೀವು ಎಲ್ಲರೂ ಹಂಗೆ ಹೇಳ್ತಾ ಇದ್ರೆ ನನಗೆ ಒಂಥರ ಆಗ್ತಿದೆ. ಆ್ಯಕ್ಚುಲಿ ನಾನು ಅದರಿಂದ ವಂಚಿತನಾಗ್ಬಿಟ್ಟಿದ್ದೀನಿ ಊಟದಿಂದ. ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್. Now I would request Dr. A.M. Ramesh sir, Chief Executive Officer KSTA, for a short sum up, sir.
Good evening, everybody. Thanks, Dr. Samad, for reminding me to finish fast, because I am standing between the price and the... So, I am extremely thankful to the esteemed guests of today, Dr. Shashidhar sir, Director NCBS. I sent a mail, immediately he replied, he can't give a talk, but he comes for valedictory. I am very grateful to you, sir. A great scientist, immediately replying, really I am elated. Similar is the case with Dr. Prabhuraj and Dr. Swami. When I invited them, immediately agreed. And all the 10 experts that we had invited for the talks, they also responded very immediately. So totally, I mean, experts on the panel also were quick in their response. So everybody was keen to come and deliver talk and broaden the horizon of our knowledge. I'm very, very grateful to the experts, the valedictory guests, inaugural guests. Dr. Dadwal gave a fantastic talk, and Dr. Ramakrishna also gave a talk, very good talk. And all the panelists spoke so well that students got a lot of take-home message. And in fact, KSTA had organized many environmental related conferences, but exclusively I wanted a conference on climate change, because everybody was organizing, KSTA had not organized. So this time I thought I should shoot up a proposal to Ministry of Earth Sciences. They immediately responded and gave just 2 lakhs they gave, and others also chipped in. Our Dr. Prabhuraj sir gave 50,000, SBI also gave, then Prakash Panjas gave, and NABARD also gave some money. So totally, I must say, the effort I started was at a good day, most probably. That's why we got good response, and also delegates. Last 15 days I was seeing not many were there. Immediately in last 2-3 days we got more than 40 papers for presentation. In fact, 60 papers were presented orally, and some 9 models were there. So today the prizes will be distributed. Those who get prize, congratulations. Those who don't get prize, certainly KSTA would organize many programs like this. You will certainly have opportunity to get prize next time. So in the feedback, I thought we always get good marks. I thought somebody will say some flip side of the organization, but everybody says it was good. Thank you very much. Have a great future. All of you should become climate warriors to stop further climate change. Thank you very much.
ಸಮಯ ದಾನ ಮಾಡಿ ತಮ್ಮ ನುಡಿಗಳನ್ನು ಮೊಟಕುಗೊಳಿಸಿದ ಡಾಕ್ಟರ್ A.M. ರಮೇಶ್ ಸರ್ಗೆ ಧನ್ಯವಾದಗಳು. ಈಗ ರಮೇಶ್ ಅವರು ಹೇಳಿದಂಗೆ ವಿಜೇತರಿಗೆ ಬಹುಮಾನ ವಿತರಣೆ, ಪ್ರೈಸ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್. ಸ್ಟಾರ್ಟ್ ವಿತ್ ಓರಲ್ ಪ್ರೆಸೆಂಟೇಷನ್. ಇಲ್ಲಿ ಫಸ್ಟ್ ಪ್ರೈಸ್, ಪ್ರಥಮ ಬಹುಮಾನಕ್ಕೆ 10,000 ರೂಪಾಯಿ, ಎರಡನೇ ಬಹುಮಾನಕ್ಕೆ 7500. ಥರ್ಡ್ ಪ್ರೈಸ್ 5000 ಆ್ಯಂಡ್ ಕಾನ್ಸೋಲೇಷನ್ ಪ್ರೈಸ್ ಸಮಾಧಾನಕರ ಬಹುಮಾನಕ್ಕೆ 3000 ರೂಪಾಯಿಗಳು. ವಿಲ್ ಸ್ಟಾರ್ಟ್ ವಿತ್ ಸಮಾಧಾನಕರ ಬಹುಮಾನ consolation prize. The consolation prize goes to the topic evaluation of energy performance of hospital in warm humid climates through building energy simulation method by Harshalata, Shantaram Patil and Pradeep J. Kini. Please hurry up to receive the prize. The third prize goes to studies on sex expression of novel pistillate lines and their sustainability for climate resilient hybrid development to yield maximization and better adoption of understand change climate conditions in Castor, that's in business communities. That's the presentation by Yamanura R. Mohan Kumar, SC, Ranganatha, T. Manjunath and C. Lavanya. All India, the consolation was from Manipal School of Architecture and Planning, Manipal Academy of Higher Education, Manipal. The third prize is All India Coordinated Research Project on Castor, Zonal Agricultural Research Station, University of Agricultural Sciences, GKVK, Bangalore. The second prize goes to impact of polyionic liquid interface on photostability in wide bandgap solar cells. That is Altaf Pasha and R. Geeta Balakrishna. They are from Center for Nano and Material Sciences, Jain, that is deemed to be University, Jakasandra Post, Karnataka. The first prize goes to, give them a big round of applause, impact of weather parameters on the occurrence of paddy yellow stem borer, that is Sirpophaga insulatus, by Balaji B.N., Vijay Kumar and Shivanna. It's from University of Agricultural Sciences, GKVK, Bangalore, Karnataka. So this is the prize for oral presentation. Now, for the exhibited models here. The third prize goes to Skywatch Air Monitoring Drone by Sinchana H and Tanmay N. Here also the first prize carries 10,000, second prize carries 7,500, third prize carries 5,000 rupees. The second prize goes to carbon dioxide reduction and sediment water pollution controlling, that's by Purvita R and Vasavi H. And finally, the first prize goes to realizing off-grid sustainable residence using third generation solar cells and green hydrogen fuel. That's by Altaf Pasha. Once again. Thank you all the dignitaries. The end of the story is the new beginning. With this note, let's conclude a remarkable, memorable, knowledgeable and scintillating national conference, that's Climate Resilience and Sustainable Development. With this, I would request now Sri V.K. Srinivasu, Scientific Officer, KSTA, to propose the vote of thanks, sir, please.
ಥ್ಯಾಂಕ್ ಯು ಸರ್. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. ಎಲ್ಲರೂ ಬೇಗ ಹೋಗಬೇಕು ಅಂತ ಅಂದ್ಕೊಂಡಿದ್ರೆ ಜಸ್ಟ್ 2 minutes I will finish this. Respected dignitaries on the dais, of the dais and dear delegates. I, on behalf of participants of this program, KSTA, and my own behalf, a very hearty thanks to Dr. L.S. Sasidhara sir, Director NCBS, accepted our invitation to grace this valedictory function. Thank you very much, sir. Thank you, sir. We are very much thankful to Dr. Prabhuraj sir, Director KSRSAC, for supporting not only this program, and sir has been supporting and encouraging our programs. Thank you very much, sir, for accepted our invitation as a chief guest and grace this occasion. On behalf of all of you, heartfelt thanks to our Chief Executive Officer of KSTA, Dr. M. Ramesh sir, for his guidance and encouragement for organizing this program very successfully. And I also hearty thanks to Dr. Swami sir, Dean, College of Horticulture, for gracing this occasion. Heartfelt gratitude to Ministry of Earth Science, Karnataka State Remote Sensing Application Center, Power, Sponge and Iron Private Limited, Turbo Steel and Karnataka Science and Technology Promotion Society for sponsoring to arrange this 3 days national conference on climate resilience and sustainable development. We are very much thankful to all the resource experts delivered the distinguished lectures in all the 3 days, and also thanks to chairs and co-chairs of the sessions. Heartfelt thanks to all the panelists. They are sitting, they are very well-known scientists, for sharing their insightful knowledge and wisdom, and also advisory and organizing committee members for organizing this program for their valuable guidance and support. And great thanks to all the delegates, participants and invitees who have made this conference grand success. Particularly, I am very thankful to Dr. Anjagi sir, as deputed almost 57 delegates from Bangalore University. Thank you very much, sir. I also thanks to all my colleagues of KSTA and also our housekeeping and also security personnel for their support for conducting this program. Extend my heartfelt thanks to print and visual media, particularly journalism students. They are roaming here and there and shooting videos and photos. Thank you very much, all of you, for your presence. Thanks to those who have helped directly or indirectly made this program grand success. If I miss anybody, don't feel bad. Thanks one and all, and thanks all of you gathering here. I wish you all the best, and I wish happy and safe journey to your all. Thank you one and all.
I also thank Shri V.K. Srinivasu. ಈಗ ನಮ್ಮ ರಾಷ್ಟ್ರಗೀತೆಗೆ ಎದ್ದು ನಿಲ್ಲುವ ಮೂಲಕ ಗೌರವ ಸೂಚಿಸೋಣ. ಕೈಂಡ್ಲಿ ರೈಸ್ ಫಾರ್ ದಿ ನ್ಯಾಷನಲ್ ಆಂಥೆಮ್ ಸರ್, ಪ್ಲೀಸ್. बोलो भारत माता की। ಎಲ್ಲರೂ ದಯಮಾಡಿ ಈಗ ಒಂದು ಫೋಟೋ ಸೆಷನ್ ಇದೆ. ಪ್ಲೀಸ್ ಅಸೆಂಬಲ್ ಎಟ್ ದಿಸ್ ಬಿಲ್ಡಿಂಗ್ ಎಂಟ್ರೆನ್ಸ್ ಫಾರ್ ದಿ ಗ್ರೂಪ್ ಫೋಟೋ. ಆಮೇಲೆ ಪ್ರೈಸ್ ತೊಗೊಂಡಿರೋರು ದಯಮಾಡಿ ಪ್ಲೀಸ್ ಸ್ಟೇ ಬ್ಯಾಕ್ ಆ್ಯಂಡ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಪ್ಲೀಸ್ ಪ್ರೈಸ್ ಯಾರು ತೊಗೊಂಡಿರೋ ವಿಜೇತರು ರಿಸೆಪ್ಷನ್ ಹತ್ರ ಬರಬೇಕು ಆಫ್ಟರ್ ದಿ ಗ್ರೂಪ್ ಫೋಟೋ. ರಿಜಿಸ್ಟರ್ ಮಾಡಿರೋರು ಸಹ ರಿಜಿಸ್ಟರ್ ಮಾಡಿರೋರು ದಯಮಾಡಿ ನೀವು ಕಿಟ್ ಕಲೆಕ್ಟ್ ಮಾಡ್ಕೋಬೇಕು. ಪ್ಲೀಸ್ ಅಸೆಂಬಲ್ ಎಟ್ ದಿ ರಿಸೆಪ್ಷನ್.